that the pre-order traversal approach is quite important. So today we're gonna solve lead code problems where we can apply this approach. By pre-order, we mean that the stuff we do before calling our recursive function. Obviously, you can use this method on various topics like on trees, on backtracking, on dynamic programming. Um, so, but this is quite essential. So I gathered some problems um, where we can apply this logic. So let's start. And good morning, good morning. Welcome, welcome, Americano. How are you doing, man? How are you doing? Seems you there's some problem about yesterday. And let me update the topic. Um, Predator approach. Apply. No, no, no. I created some new commands, chat commands, so that it is easier to control the Pomodoro. Welcome in. How are you? Today we're gonna apply pre-order traversal approach. So let's dive in. Now we have this question, and what it asks is like all subsets. So what is subset? I think we have solved a question similar to this, right? One, two, three. We need to create this. Um, actually, we have solved this. Yeah, yeah. Actually, in our last stream, the last question was this. Um, one, two. So let's try drawing its decision tree. All right. The pre-order pre-order we are applying is that like it happens when when we are going down. All right. This represents the argument that our parent gives us as a child. All right. So when we look at here, we like what I see is that like one, two, and three. So and also our options is one, two, three. So imagine we have these options in level one. So this is level one. Um, and then what we have is like a 1 2 and 1 3. So after 1 I see that we have option 2 and option 3. All right. And we have 2 3 and we have 1 2 3. So I think like now I'm thinking that how we can get this like 1 2 3. So this is our decision tree. And now the thing I'm trying to do is that like in each level we have options, but they shrink. So we need a mechanism that is shrinking. So let's imagine. I know, like this is our general structure, right? Like we are imagining a function, and we are applying our choices, and like this is choice we are making. So this is the overall structure. We have one, two, three, and then as we add one, our choices become two and three. And like if we like after making this choice, when it returns, all right, um, we should remove the choice obviously to make the new choice. So okay, we need to I need to handle these ads. Um, quick ad break, but no ads. Like I tried to create some demons to handle these ads so that it is smooth, but apparently it is not smooth. Um, let's see. We will figure out how these ads work. Um, like, can I do something about it? All right. Um, let's see. Actually, I don't know, man. Let's see. All right. Like now, we need to find a way. Like we like from post-order traversal approach, we know that like doing this is post-order. All right. Like we call our recursive call and we imagine ourselves like what will happen after this return. So when this function return, all right, we should remove the last choice. All right, this is post order, and this here in pre-order. What we are doing in pre-order, we should append, obviously, append the current character and create like imagine we have a temporary array, all right, then so we append it and we create a call, and when it returns, we remove. But from this perspective, like we have for loop and let's see, one, two, three. Obviously, we have our choices here. All right, one, two, three. We append it, we make it, we create that world, and when it returns, before going to the next choice, before going to the next choice, we remove it. Like at the same level, when we are trying to, when we want to try the next choice, we remove. That's awesome. So this seems alright, but imagine we have like a chosen this, and then now imagine yourself at level two. In level two, and where your parent is one. All right, all right. Should I copy this and recreate it? So Americana, I figured that like this pre-order approach is quite resembles to greedy. In greedy, we have running state approach. Today we're gonna make a focus on this, and this is gonna help us a lot. All right, because if you know post order and if you know pre-order, then uh, there is nothing that you can. There is nothing can stop you. All right. Um, So actually, there's structure will be same. So imagine our parent is now one, all right? Like we have temporary array and we have, let's say, one inside it. Our choices now is not one, two, three, but two and three, all right? And again, we append, all right? We append our current option. We call it like we append our option and create call our recursive call, and when it returns we're gonna remove it and then apply the next. But in this question the important part is how do we exactly uh, like shrinking our choices, all right? Because upon calling this function we need a way for limiting, like let's say we add 2 here, all right? In the next level, like in the next level here, we shouldn't be able to use 2 anymore. Maybe we need some sort of used array. Like yesterday I have studied this and I've seen something like a used, all right? So storing the the choices we have used. Smoker, welcome in, welcome in. Good morning. Are you actively applying for positions while studying? Yes, actually. How is the job market over there for Stefan? Like, like I don't apply for jobs heavily, but for the interviews that I attended, I figured I first should complete these topics, all right? Um, but the best way to get a job is referral by referrals. This is what I have learned actually. Because you apply for a job and 1,000 more applicants apply the same job, like just like you. So if you have a friend or a referral, it is much easier. This is what I learned. I will try applying for remote jobs too. So the like I need to like internalize these topics. I know what they ask, and we study Java, Python, and LeetCode in these streams, like in the channel. So wish me luck, guys. Like I don't want to talk about the market right now, but the thing I know is like it is like it is changing obviously, and thank you, thank you, Americano. And I think nowadays the best way is like via referrals. Market sucks right now, might rebound. Yeah, yeah. Trust and hope, as Americano says. Let's see, let's see. So we need a smart way of shrinking the option. So maybe it is via the used array, so that as we append, we can like use something like maybe like a used to plus plus, meaning that we have used this, and like right here we can also have like a if the current option, if if the current option, current like this is choice, uh, is equal to 1. I have an interview for tomorrow and on Friday. Oh, I'm getting I keep getting hits. I just need to want to go all the way and land it. Good luck, man. Good luck. It is very nice. It is very nice. I we wish you luck. That's amazing. I hope you'll get you'll do amazing. So Like if the current character is used, now um, we should continue basically. So we are literally masking the already um, applied choices. Thank you, thank you. So basically, if it is used, if the current option is used, then we should continue. All right. By using this way, we can make sure that we shrink our um, our option pool. All right. This is how we do it. This is literally how we do it. As we make choices, like here in this stack frame, the used array like should be like a used one is one, used two is one. All right. So in this stack frame, in its for loop, actually before the for loop, no, inside the for loop, yeah, inside the for loop, we are um, processing our options, and before this appending operation, we have this if, and since 1 and 2 is equal to 1 in used array, we are going to solve. All right, we got the idea. Let's continue with the other question. Before continuing, let's save the screenshots. I think we got this, guys. Like, only thing we need to care about is which level we are in, like the on the way down, and what should we do at the same level. All right, this is all we need to think about in this type of questions. Let's see. Now we have subset 2. Let's see what sort of question is it. It is. Let me take a screenshot. It is slightly different than ours, but of course it says given an integer array that may contain duplicates, return all possible subset. Must not contain duplicate subset. So again, duplicate detection 1. So actually it would be great if we have the previous question too. Let's see which duplicates we have uh, in this. Actually, let's copy this part along with the original one. Alright, this is new one, and this is original one. Let's see the difference. Alright, this is original. In original we have 1 2 3. Do we have 1 2 3? No, the input is also different. So in this question duplicate, let's say we have the same number. Alright, we obviously have let's see the behavior change. Like we choose the first one. All right. After the first one we pick this one. Yes, yes, so I think I got the idea. Like what it says is like imagine we have actually three options, right? Three items. So these are options in each level, but the thing is, let's say after selecting one, our options is not options are not gonna be like a same, all right, like this way. So we need to change this. Let's see. We need to find the decision tree that works for our case. Let's see. So, like after 1, 2 comes. Yes, all right. So, like after we make our choice with 1, we can get 2. It says, all right. We can 2. We can get, like after making this 2 choice, we can get other 2 too. All right. I think this is other, yes. So maybe we can use this sign to indicate the difference. And now we have option 2, yes. And we, like 2, 2. So, like after the first 2, we can have this, but for this, the occurring, like a duplicate 2, like this original and this duplicate 2, right? After original 2, we picked like a duplicate 2, but after duplicate 2, we don't do this, alright, calling with original again, because otherwise we would end up with, same, like a 2, 2, and like, and this is not something we want. Alright, so now we need to find a smart way of doing that. And what is that? Uh, what is that? So, all right, let's see. So, take this path as an example. All right. Like this structure, like the common, the skeleton of structure is like this is our function, and we have some pre-order stuff over here. All right, and then actually like pre-order can be here as well, and inside the for loop as well. So everything before the recursive call is basically pre-order, and after the after our recursive call, now we have some post order stuff. All right, this is the structure we have, or maybe even I should put kind of this. All right. Like let's say we, like in first level we have all the options, right? We have all the options. So imagine we have, like as Americana said before, like this the first node is empty. So here when we like call our recursive function with empty array, all right, our options, like when this is parent, our options is, I mean, everything, every element in our um or guys, not every element but the unique elements. What do you say? um let's see, because like we need to determine which two is this, like which two is this. I think it is the original one, meaning that we don't even have these guys. Do you see it? Do you see it, guys? So the smart way should be in the same level. If you have duplicate characters, you only store, or unique characters basically, all right? But the thing is, guys, like this is, like I can say this for the first level, but imagine how would it be in level 2, all right? Like in first level, let's say we hold like the unique ones, when we go to the next level, like which two is this again? Is it original or the duplicate one? Hmm. That is strange, guys. We need to think about it. Like because at one level we exclude the duplicate option, but we need to bring it back. We need to bring it back at level 2, and obviously in level 3 too, guys. Yeah. How do we do that? How exactly? One, like this is one, this is one two, this is one two two, this is two, this is two two. So yes, let's read the question again. The solution set must not contain duplicate subsets. Duplicate subsets. Oh my gosh, so duplicate subset. Do you have like any suggestion here, guys? Don't hesitate to share, guys. um, while you are thinking, I can change this uh, break thing. Let me open. I need to update my subscription, but actually I have used the open source one. But after the update, it got the original one. Alright, let's see, let's see. What do you think, Americano? So, like, thinking that at level 1, we should only care about the unique ones is kinda easy. But um, if we do that, at level 2, things got messy, basically. But maybe, let's say we sort these, alright? Let's say, because yesterday I've seen something similar to that. Let's let's assume we sort input array, alright? And let's say after making a choice, like like we are in the same level, all right? Like we add this, we remove this, and we add it, and we remove it. But somehow let's have a variable that holds the last choice information basically. Actually, since this is for loop and this is our choices, yeah. So let's assume we have this system, all right, comparing the current one with the previous choice. If it is um if the choice is same with the previous one, then don't make it. So we can have some pre-order stuff, pre-order condition, all right? And we can say that if pre prev choice, oh my gosh, let me hit here, and also this one, I think, yes. Hold on a second, guys. So where's my pencil? If the previous choice is equal to the current choice, then we can continue. Let's say we do this, all right? So that we don't make this recursive, like we don't explore this option. And now let's assume we are at level 2, all right? um Now we're gonna think something out. All right, hold on, guys, let me fix this. How should I prevent it? All right. So I think in 3 minutes we have another ad. All right, we will figure this out. So let's say we made this choice 1, all right? Now imagine we are here as a child at 2. We have our parent as 1 in our temporary array. And now, like, as we can see here, the only option, only, yes, like, let's look at one, like, oh my gosh, let's look at the subsets that starts with 1. We only see like a 1 2, all right? I mean with length 2. Hold on a second, guys. I need to do this. All right. So with length 2, as you can see here, the the only option we have is 2. So how can we make our options only 2? Mm, maybe again with same approach at the same level. If, by the way, we need to subtract or shrink our like option, this one, like after using one, obviously, right? We should have two mechanisms. um First one is like a shrinking our options as we go down, and the second one is at the same level. When at the same level, if the next choice is the same, all right, with the previous choice, so we basically extract it, all right? I think if you figure this out, this should be possible. So let's look at this example. We have made this choice, All right, now my voice ink is back. Let me move it here. And all right, we have like in 15 seconds we have an ad break, but let's see. Uh, we will figure this out, guys. So if we have these two shrinking version, we're gonna handle. Wait, hold on a second. Yeah, no, it didn't change, right? Wonderful. No, it is. All right. Now we are back. Um, now we are back, guys. So if we have these two ways, then everything is gonna be fine, guys. Let's see, let's see. I think because if we think about, like, let's say we have made these two choice, all right, and as we go down with the help of our first shrinking approach, we extract these two from our um, choices. But the thing is, guys, I realize that we don't have one as an option here too. Why? So I think we need another array to another storage mechanism to communicate between the other choices at the parent level with the current choice. That is interesting, guys, because we don't have one as an option here. So it is because at the previous level we have made this choice already. It means that imagine we have a used array, all right, and at this like a level one, let's say we made like a use one as one. So we basically don't update this one as this option returns in post order phase. We don't update it, and we give this array reference to here as well. I think we share. Hmm. I think, guys, maybe we can use only um like by using this used array, and maybe it can be enough. This is what I mean. Um. Let's share this information with siblings. All right. When we are here, we have this knowledge, and when we go here, we have like a we have this like a use to as well. So in pre-order, we can look. But the thing is, guys, the mechanism that eliminates using this option, like duplicate 2 at level 1, is different than the shrinking mechanism for between different levels. So maybe, guys, what I should do is that just copy this part, all right, guys, and think about it again. Let's remove that. Actually, it can stay, right? Actually, this is not R, but actually this original. This is duplicate, so we should have this. This is original. This is original subset. This is our subset. All right. Uh, So let's see. This is subset, right? Subsets 2. Uh, yeah, this seems good. So apparently, actually, I can remove these arrows as well. I need to think fast and all right. So we have these options, all right, at level 1. So this is level 1. This is level 2. And this is level 3. These are decision tree. So now I'm trying to find a way to, translate this into code. We have one here, one, two, one, two, two. Yes. So at level 1, we have all the options, but actually we don't have it, guys. Like we have only 1 and 2, right? 1 and 2, but we don't have like a duplicate 2 as an option. So basically, we don't have this option here, guys. All right, but maybe I can draw it using red dots. All right, we basically eliminated this choice. All right, and at level 2, the options we have eliminated are, I mean, 1, maybe, yeah, 1, and then the duplicate 2. All right, like we have eliminated, and here, like this is obviously duplicate 2. The options we have eliminated here, I mean, oh, but like we need to also be careful about when exactly we eliminate, because for example, at the same level, all right, so maybe say I should call same level elimination, all right, and inter level. Let me call inter level, I don't know if it's a word or not, but inter level elimination. We have two mechanisms to shrink our choices, all right. What are you doing, TV Josh? Welcome in, welcome in. Today we are studying like a pre-order traversal, and we are solving different like a different like from questions from different topics where we can apply pre-order and post-order as well. But our goal is internalizing the pre-order approach, and now we are solving subsets 2 problem. Welcome in, welcome in. How are you doing? Now we are trying to solve subsets 2, and now my focus is on the elimination phase of our options choices, because this is the core part. Like this is our decision tree. Like um, we have two elimination mechanisms as far as I see. First one is first one is happening in the same level, and the second one is between the levels. Like because let's see, like we have like we choose 1 and then remove it, and then we pick 2 and then remove it, like in temporary. Here we don't make this choice again, so at the same level we should have a mechanism for understanding that we we have already made this decision with the same number, right, with 2. Like we can apply this using used array, and we can increase its key like this, all right, and then the problem is solved, right? But how how can we like how can we do it between the levels? So we need a different strategy over here. Let me, yeah. So so like this can be same level because I've seen this before. Maybe in permutation 2 problem. Um, but like let's see what happens. What is happening on level 2? All right. In level 2, here, where can you turn your mic volume up? Let's see. Let's see. Like since it is too early here, I don't speak. You know, but I can maybe increase the volume from the microphone itself, I think. Let's see. Receiver, transmitter settings, transmitter gain. Yeah. So maybe I can increase. How about? I think now it is better, right? I'm not asking you to speak. Yeah, now I'm not speaking like on OBS. The setting is at 100%. Now I increase the decibel from the transmitter gain. That's good. All right, all right, all right. Wonderful. All right. So, um, so imagine like when our parent is one, guys. All right. Imagine we are like in a stack frame where our parent is one. All right. We have a for loop here, and we are making the recursive call. All right. Um, So here, guys, in this for loop, like let's see, like we don't make a choice for one and then the two. So you can say that, mm, oh, like the thing is, maybe we should reset this when we go to the next level. Which problem is it? It is subsets 2. Lead code subset 2. Um, 90. Question 90. Subsets 2. Like, let's focus on the fact we have. The fact is, when our parent is 1, we don't have the first option, like a option, I mean, value 1, option with choice with value 1, and choice with value 2. You may say that at the same level, the reason why we eliminate this is because we use this option. All right, because at the same level, if we have like a used uh, a number before, we can use this used array and say that like we apparently add an if statement over here, and we don't make this choice. So this is, let's say, um what we have called, like two options we have. So same level elimination, let's call it SL, and this is IL. So same level elimination, SL. So this is SL. All right, this is because of SL. So the reason why we don't make this choice, oh my gosh, at least level 2 is another thing, all right? And this is about, this is because I think it is because we already, uh, like, is it because we already made this choice and it is in our like a temporary array? So, but what would happen if we make that choice again? Like, I wonder what would happen if we make this choice again. I mean, like we would have 1 and 1, Like if we don't eliminate it, yeah, like we would have this kind of stuff, I think. And we shouldn't use the same option we made in previous level as well. So I think, guys, how about guys, we create um used level, all right? Let's call it used level. Used level. And here we can pass this array reference, all right, as we go down, indicating the choice we made in the previous level. Let's say we have two arrays, one for same level and one for interlevels. All right, interstellars, interlevels. Um, so that using this second array reference, we can eliminate this option because it is used in. So like this seems legit. Like this seems this can work, but how about here? Um, at this node. At this node, in our used level, our 2 is 1, so that we don't have this option here. All right, this works, but also we don't have 1 either, as you can see, like we don't have 1 here. All right, and what eliminates it? Oh my gosh, what eliminates it? Let's see. Maybe I should just give I need to give better naming to our arrays. All right, memory array. So like at the same level, guys, if we use it in our for loop, if we use it, so let how should we call it? Let's say um used for loop. let's let's say you at the same level, used at the same or same level, used same level, used same level. Wonderful. And our second array is for interlevels. Used interlevels. So here, all right, maybe I can just type it too, guys. Which application I was using? Oh my gosh, I built a tree for this. Like this is my decision tree. But I think it is like backtracking problem. But what do you mean by build a tree for this? Lexical. Oh my gosh. What was that again? Maybe we can just use this one. Oh, new. Alright, and let's turn it into code. Zoom in and let's try typing our code. Alright. Let's say we have a void method. Alright. Awesome. And here we have our for loop. All right, not this parentheses, but curly, and inside it we make our recursive call, and our function takes an integer, um, like a temporary array. But it would be great if we have something like a remove subset submissions. Let's see. Submission does not exist, it says. Like loading, I think. All submission. We don't see it yet. TV Josh. I think I need to log in. Maybe that's why. No, I'm not logged in this account. Let me open my LeetCode account then. So let's open it. So accepted. This is your solution, and so when I open the code, how am I supposed to here? All right, your code is here. This is in Python. What do we have here? Get sets. Subsets with duplication. An array. Use sort. No. So we have a function here. I'm trying to understand what you have done here. Get sets method. So basically you didn't apply backtracking, I think, here. But obviously you need a way to get sets traverses the tree. Alright. It has for loop. Not really. I see. The way I am doing is like using recursion and applying, backtracking. I think you didn't apply recursion here, right? But I'm using recursion. But I definitely check out your, iterative solution. It is recursion. How? I guess yes, alright. I see. So what is your logic here? So you said three. Like it should mean that you are building a tree, or I don't know. How do you create a tree and then traverse it? Let's look at the Java equivalent of it. Give me Java equivalent of it. Edkit etnos. All right. I wonder the way you know recognize the duplicate elements. Like here in my solution, I have two approaches for the same level and interlevel. But I'm trying to make sure that these two elimination strategies will work for every node, basically. Because here, like we eliminated choice 1 and this 2. Like interlevel elimination helps us to eliminate this node, but how do we eliminate this one? Because like this is the logic issue with my approach, I think. All right. Index 0 to 20. All right. Add kid. So for me, adding kids would be like a at position 2k plus 1 and 2k plus 2. Um, you are calculating the insert index like this. So so we have our input is integer array, so that's why you do this. But how exactly position your nodes? Like insert index says plus 10. That is a strange formulation. For loop, if it is null and if it is insert index, the values are minus 10. Do we have this information? I think yes. That's why you were able to use this approach. That's interesting. I haven't I even haven't looked at this because um like my approach should work in any case. I think I didn't think about that rule, that constraint. But the thing I'm struggling with, as I said, is like a communicating between these two. I should eliminate one. So maybe as we share the choice at the same level, all right, we can share this used array, very same array, while going down too. So maybe this can solve our problems. Like you calculate the insert index and you are inserting. If it is not, like I didn't understand how you managed to create this tree. Maybe I can create a visual, like an animation, but let me first you also sort. So yeah, I should sort to. Let's see. I will try generating an animation for your approach and see the visual movement because at first glance I don't understand it. Thank you for sharing, and I will compare your time complexity with mine. Um, so I think like if we share the very same temporary, if we share the same used array while going down to, the problem will be solved, I think. Let's see. Let me copy this part. So I think we only need um, one used array, but we should um, share it. Uh, we should share its reference with our children as well. All right. So imagine we have. Actually, we can type it, right? Let's type it. So, like, imagine we have a used array here, all right? And imagine we have a choice, like we iterate our choices, all right? And what I mean is that we need a reference for our used. Like this is what I mean. So from our parent we have this information as well. So but at the same level, when you make a when you make a like before you make a choice, we should increase its this field, this value, all right, so that if I mean if its value is uh, oh my gosh, we are back. If its value is greater than 0, then we should continue. Like this is what I mean, all right. And if it is not used, then we can make this, I mean, choice. um how do we call our function? By like, and also hmm let's append here, like here exactly. If I can make this choice, we can append. So to append, I need some sort of array list. So instead of this one, let's, I don't know, like something, let's have something like that, so that append this, all right, this choice, and then share the reference, all right, and also share the reference of this one. So I think we are getting closer, guys. I think we are getting closer. Like we need a smart way to eliminate our choices, all right, and all right, and the last idea I have is this, all right. Let's see if it will work. So at level 1, guys, we like our options are 1 2 only, but we eliminated this option, the duplicate. So it means that at the same level, guys, at the same level, after making this choice, we okay, we have some sort of this logic, all right. I mean, we need to do this, all right. And in our for loop, in our for loop, yes, in our for loop, like we make a choice, and then for next option, we see if it is bigger, and if it is, we don't make a recursive call. So basically, our solution works for this part. But how about level 2? We made a choice with 1, and now in our choice, I mean in our solution, we um, we pass the reference of this array, all right. So this holds, um I mean this holds. So after making this choice, we make a recursive call. So here the used array, I mean here used array has this information, all right, this information. So we made a call. Now we are here. Our options, I mean, of course, 1 2 3, but the eliminated version is, I mean, since we have 1 in our reference, in used reference still, all right, like there is nothing wrong to increase it again, all right. It was 1, we increase again, it is 2, and it is bigger than 0. So we continue basically. Like when our parent is 1, all right, when our parent is 1, in our used array we have 1, so we basically continue this. But the thing is, guys, if we do this before this one, then we won't be able to make any choices at all. So the used thing should be after the checking, all right, after checking if, all right. So like when our parent is 1, and when our parent is 1, in that stack frame, in this used array reference, we have 1, all right. And when we are trying every option, the used one is 1, so we don't process this. And in the next iteration of this for loop, we iterate 1, all right, and it is 0, and we increase is used, and then append it and use it. Wonderful. And then in the next iteration, actually it is not 3 but 2, duplicate 2. So in this iteration, now we put 2 here again, and it is bigger than 1, so we don't process. Wonderful. Wonderful. But the thing is, guys, oh my gosh, now my approach failed at this. Oh my gosh, at this note, guys. I'm very sad right now. So here, guys, at this level, if we share the, you know, reference of these used, at this level, at level 1, we added 1, all right? And at level 2, we added this one, I mean, we increased. So here, guys, in this static frame, all right, inside the for loop, all right, we won't be able to process this because, oh my gosh, like I thought my approach would work, but it fails again. This is very sad. Like maybe we literally should use 2 different used arrays, one for same level, one for across levels. Maybe I just should, yeah, like this will solve, guys. Just create used uh used across, all right, used across. So used is for same level, all right. Let's see. We need to, fill these arrays carefully, and then we're gonna be okay, all right. We're gonna be just fine. So let's suppose we are at level 1. Our options are 1 and 2, all right. And at the same level as we make this, so we are inside for loop. We make our choice, append it, and all right. So also we should remove at index. We need an index. Americano, oh wow, really sorry, I find welcome back, Americano. How are you doing? Maybe temp that size like this one and -1. Welcome back, Americano. So all right, guys. So like we make this choice, all right. What problem is this now? The problem is subset 2. Subsets 2. Oh, same. Yeah, it's the same one. Like when you put it like that. Wait, it is 1, 2, 2. No. Like yeah, like it is not 1, 2, 3, but 1, 2, 2. Like subset 2. Like I've been trying to solve this question for some time. All right, let's hope for the best. But I think we can handle it. All right. So imagine we are at this level and we make our choice. All right. All right. We make our choice, and when it returns, we should remove it, because if we don't, then we make this choice, then it will be this one. So we don't want it. So we should remove it. All right. After Like this is post order, guys, post order truth. After this returns, we remove it. So after this one returns, we remove it so that we make this clear call. But the idea is we eliminated this approach. How do we do that? Using, of course, you guessed it right, used array. So if it like, so this is for same level elimination. All right, now we need, like, we can now eliminate this option. All right, but how about across levels? Let's see, let's say we have made this option like with this choice one. All right, and we called our function with temporary array. Now our temporary array holds one inside it, and in the next stack frame our parent is one, and now um, we need a smart way to not to use one. All right, so that maybe guys, maybe we can have just um what was it again, used across. So this is inter levels. All right, maybe we can have like something like that. And if one, if it is let's say greater than 0, we should just continue. All right, and where we like, actually here used, oh my gosh, what was the name again, used across. So but what is the difference? The difference is will be where we update these arrays actually. Like let's see. What was the name of it again? Used across. So we basically indicate that we put this into our temporary array. All right, and um, all right. So this when this function returns, we shouldn't change this used. All right, but as we go to the next level, we should reset this array, right? Like the first approach that I applied was working for, I mean, first level, and then the second levels first node, but it didn't work for level 3, because at level 3 we eliminated the first two approaches. So we need to transfer this knowledge, and that's why I'm trying to use this used across and share it. But this is exactly same as this one, so we are missing a point. Like at the same level, we increase, we make a call, like I don't see it, guys. Maybe I should just activate the, you know, tutor mode 2. Let's suppose like here we have, like, we all hold 1 and 2, but the thing is, guys, is not eliminating the options, like options 1 and 2, but instead not eliminating this one, like at this level 3, because the approach I'm using is like a can eliminate these options, but if they do, they also eliminate this one. But here we literally need to use the duplicate thing, maybe now I think that maybe we can have some ordered information. I don't know. Like I don't wanna spend more time, so maybe we just uh like activate this one and get some help. Like I can spend more time on it, obviously, but I don't wanna do it because I wanna solve other questions too, alright? Well, I think we added. Mm, maybe I should just close and reopen this app again. Uh, it doesn't start. Let me check the shortcuts. Actually, it should work, but it doesn't. Hello, hello, hello. That is strange. Mm, maybe because of the uh, permissions. Alright. Now, the thing I have tried for this question is that I tried using used array and sharing its reference. Um, I mean, at level one, it is easy, alright. At level one, it is easy because I think we had similar data structure in permutations too. Lead code problem as well. And like I used array and used array, and at the same level it works because after making choice, two, like we eliminate the next same duplicate. But um, and also at level it works too. But here at level two, we should also know our parent, like choice of our parent. So apparently we need an argument, all right? We need an argument. So I thought maybe we can use another used array for parent to child. I mean for you know inheriting this choice from parent to child. It may work, but the part I struggled with is at level 3 we have this duplicate 2, all right? Either I draw the decision tree wrong or like we need something else too. So can you guide us? Mm, oh my gosh. Oh, I think I should open history and copy from here. All right, let's paste it. Like, I don't want to spend any more time. The part I struggled with is this, like, how do we make this choice at level 3 basically? Because let's say if we use an array, used array, and add this 2 into our used array, and then here we have these 2 used. So we cannot use this duplicate 2 again, but we should. Um, so maybe we need a structure. I don't know. Maybe we need a structure to distinguish these duplicates just for this leftmost part. And actually we have the same problem here too. Like if we add this to here, and if you go here, like as I said, this combination, like we can build this communication here, all right, by sharing the reference of used array. But it is dangerous, you know. It is quite dangerous. Let's see how AI will tell us. This is a duplicate handling twin of subsets, and it sits right in your backtracking table. The table already records the key split you drilled. So before the duplicate problem, one question. In plain subsets, no duplicates, did you walk the tree with use array or with a start index? Which alright guys, alright. Now I feel like uh again we need maybe two elimination strategies, but one is using used array and the other one is, I think, changing the start index. So maybe here at level 3 the start index is 2 obviously, all right, so that it can start at last index. So at level 2 the start index is 1. So the method, like the reason why we eliminate this one is not because of some used, but instead because of thanks to the start index change, all right. At level 1 start index is 0, so we have all the options and we use used array to eliminate this one, all right. At level 2 our start index is 1, so we already eliminated this option. And let's say we add this and we add it into our used array, all right, and we eliminate this. And for this one, let's see how it works. We made this decision, all right, and at level 2 start index is 1, start index is 1, so we have options 2, I mean, like the normal original 2 and this one. But here again, like I need some parent to child, like a pre-order information transportation, because we should eliminate this one. So the reason why we eliminate is quite important, all right. This is important. How do we eliminate this one? So at level 3 basically we already eliminated 1 and then 2, all right. These are our first two options, so we literally started with this one and then done with it. But here, like after making call, maybe should we share? But if we share used array here, like would it be a problem? Let's try explaining this to AI and let's see. So, oh my gosh. So thank you for the idea of start index. Now I realize that maybe I don't need to use the second used array, but instead by updating the start index, we can literally for example at level 2 we initially eliminate the first option, which is 1, right away, all right, without using any used array, all right. For example at level 3 we eliminate first two options without doing anything. This is brilliant. But still I need, like I feel like I need a mechanism where like where coming from parent, all right, I feel like I need an information coming from my parent, indicating which character it used. But if we share the same used arrays reference, then it may cause a problem too. Like at level one, all right, at level one, you by using this used array, we can eliminate duplications, which is good. But at level two, imagine we like at level, let's say at level one we made the choice, all right, and at level two, let's say that choice is not at the first position, but let's say in the middle, all right. And then we need to eliminate this, but I don't see a way for of doing it, all right. How how can we do this? Let's see. Oh my gosh. Paste it over here. We are now studying subsets to problem, and like I'm struggling with this last element. No, no, not last element right now, since we started using the change of start index. Now I understand it, but now like how do we like shrink this, like eliminate this option? All right, here at level two, like we eliminate this option. We don't make it. We only make this. So it means that from parent to child we need to know. But if we like if let's say we used array and share its reference, then we wouldn't be able to make this choice. All right, so now I'm trying to understand this part. How do we do exactly? Because the value of number is exactly the same. Good. You just killed your second use array. Now notice where your instinct is pulling you. You keep wanting info coming from my parent. Let me challenge that. Take the smallest input that makes a duplicate. Smallest input. Two branches produce same subset. Pick first two, then stop. Pick the second two, then stop. Two branches produce same subset. All right. One question: those two branches, do they have same parent or different parents? Hmm, let's see. Let's say we have input array like this one. All right. What are our subsets? 2 and 2, 2. All right. How do we do that? Let's start here and let's say our option is 2. All right. And based on my approach, we don't use we don't make this call for duplicate. And like this is first one, this was first one, and here we have the duplicate one. All right. And if we make this choice and save it, and then add this one and save it, then we would have this one and this one, which is awesome. So at the same level we need a mechanism to eliminate the duplicate, but between the levels I think we need a mechanism for moving like a pointer or something for the next duplicate. Yes, so maybe this is what we need. Oh my gosh. Let me dictate. Actually, like I feel like we need a system where at the same level, like while at the same level we eliminate duplicates, we also should have a system that like across levels we need a system to go forward to the next duplicate. All right, Like at the same level, we need a mechanism for eliminating duplicates for between the but between the levels, we need a mechanism to go to the next duplicate. I think this is the summary of what we need. Copy this and paste it. Oh, all right. Oh, I haven't. So actually, guys, if you allow me, I wanna, fix this thing, alright? Because I wanna be able to, you know, dictate easily. I guess it was in accessibility. Let's try finding our app. Well, what was it? Right now it works, but I can't use my shortcut of right in the keyboard button. I guess it is because some sort of accessibility toggle off thing. Alright, accessibility toggle off. Um, what should I do? Let's try opening the app. Alright, permissions. Alright, I haven't given the permissions. Let me renew them. Alright. Hold on, guys. I need to handle this. Maybe we should just renew. In permissions, I see. No. Site app that I didn't give permissions, but in my system permissions they seem to be here. So exactly right. That's the clean decomposition between levels. Forward motion. Same level, yes. Between levels, forward motion. Forward. So forward motion is already enough, it says, guys. Oh my gosh. But is it really? Is it really, guys? For example, this is level 1, and at level 2, the start point is 2, and here it's the start point is 2 still, all right? Let's see. Let's see if it is working. No, it is not. Oh my gosh. Maybe after the stream I can focus on this. In the app permission window. accessibility access, or maybe restart it. So now zoom only on the same level mechanism. Like in the same level mechanism, your loop at one level looks like, yes. What cheap pre-processing would make two equal values land right next to each other? Of course, we need to sort them. I know it. I think now it's gonna work. No. Permission screen. Alright, how do we give that access? Alright, now I think I have fixed it, guys. Now this is gonna be fun. Oh my gosh. Yes, but alright. We are now back, guys. But the thing is, like, this thing I am struggling is that, like, I see, like, when we go to next level, like, we can update. Oh, I see. For the same level, start point is not same with the, each sub tree. I see, I see. The start index is changing. All right. Now, now it may work. All right. So guys, I think now I understood it, guys. Now I think I understood it. So all right. So imagine like R3 is like a 1 and then 2, and we eliminate it like a duplicate 2, all right? And here, as we go to next level, we change our start point, all right? Now like start is 1, and we eliminate this option since we make this choice, all right, basically. Like, all right. So we basically eliminate it. The reason why I don't draw 1 at all, because the start index is 1, all right? But pay attention to this, guys. Pay attention to this. Like here, the start point is, guys, is 2. Yes. So this means that like we have our function, which is amazing. We have our for loop, which is more amazing. And we have our func, all right, which is again amazing. Now to eliminate our options, I thought that like maybe we can use another used array, but the first used array is for siblings, all right, at the same level, all right, because we need to eliminate this, all right, because we have used it. We used 2, and now we shouldn't use the duplication, so we use this one for the siblings. So it means that before calling function, we basically add this character and increase its value. All right. All right. So we can go into detail, but this is structure. And the important part is, oh, we need a start index. So we cannot use for each. We need indices. We need indices. So, and also we need a start integer, obviously. So we make I equal to start. All right. Um, and we use this I over here as well. And also for the next call, we give start plus one as an argument. All right. All right. But like I is 0, I is 1 here, all right? Yes, yes, all right. Yes, this is exactly true. I is 0, I is 1, so here I is 2. Like it starts from 2. All right, wonderful. And the thing is, before going into the next level, we should, I think, clear this element because we share the reference of it. All right. I think now I understand it because like um I could have thought this, but I focused on like using an array for this so much that I couldn't think about any other option. So instead of for each loop, uh, we need to like use normal for loop, and let's use a start index. All right, and smaller than what? Maybe we should pass the input array as well, guys. Input array, let's say input r. Wonderful. So it should be smaller than length of array and plus plus. So in the same level, if it is used, we continue. All right. All right. So if it is not used, we increased. It's used, and we append it and make a call with start plus one, and also input array. So I should also share this one. All right. But the thing is, we also need to clear this for what? For the next call. Hmm. For the next level. For the next level, we need clean used array. But for the same level, hmm. How do we do this in subset problem? Give me subset Java solution in Java. Like I can create another integer array for this, but like for the next for loop iteration, we should preserve this value. But for the next level, we need apparently clean one. Let's see how. Here we don't have it. So I think it was in permutations to question. Give me. Maybe it was in permutations two, as I said before. Then I have read something in the message and I thought it is not permutation two, but uh, combination one. Yes, so we have used array. Like the thing I wonder is how do we create a clean one? But I guess we don't. Hmm. But it is for permutation. Like we clearly need a a fresh, like a fresh used one. Or do we? Let's see. Hmm. It is time for it is time. It is breakfast time for me, guys. I'm hungry. I wanna take a break. Um, like I don't see it in this decision trio, right? Like if we have a little bit more, a little bit hungry too. Oh my gosh, yes, yes. Um, but before taking a break, I just wanna, you know, like understand if we like what should we do with used array when going down. Like at the same level, it is clear, but I think, guys, if we add if we add a character in used array, all right. Apologies if I am not as before. I'm time hunting for. I'm part time hunting for no reason. That's all right. That's all right. That's all right. Um, I'm also going slow, like, but after this question, we will increase the pace because I want to solve a lot of questions. Like, we have tons of questions, and I want to solve as much as possible. Um, like while calling we add, but at the same level, then should we think about the return value? Yes, because for the next iteration, it should return. So when it returns, we shouldn't clear. Yes, we shouldn't clear. But here in this permutation we clear. So it is definitely a different solution because here when it returns, we shouldn't clear them. All right. That the information of the fact that we used one should stay for the next iteration for sure. But how about the next level? Mm, like for the next level, we increase the start. Yeah, like this start update works amazing. But the thing is, like again, at this level too, we need a used array, right? Imagine we have more options, like maybe like a three, four, five. All right, we would have these options over here too. So, for example, let's assume we have lots of tools. All right, here, although we start, I mean, our start index is at far, like one far away. We need to eliminate these duplications again. So for us to be able to do that by using used array, like the thing I'm trying to get is that is used array has like does used array have anything related to, with different levels, or it is only used at the same level? This is what I'm asking for. Actually, I shouldn't spend any more time and ask. Of course, we need to say so. So the part I need clearance is that is used like, do we use array only for the same level duplication recognition, or does it have something to do with across levels too? All right. I learned that I can now clearly see that using start index update, we can easily eliminate the used ones. Amazing. But again, imagine we are at level 2, but we still some sort of used array, all right? But how should we clear, or should we clear, I mean, previous levels choices? And if so, how do we do that? So can you please clarify? Oh my gosh. Like maybe I can create a chat command so that we can dedicate only, I mean, 30 minutes at max for each problem. I don't know, maybe 10 minutes of thinking and then 20 minutes of understanding should be enough. Now spot what's happening in your own question. You keep asking, how do I manage across levels? But step back. What job is left for used array to do? Forward motion. Don't reuse earlier indices. Yes. Same level duplicate skip, sorting and comparing neighbors. So this is the core idea, but um, still, I'm not quite 100 percent sure how to use used between the levels. So try writing the same level skip condition using only start. I and now, same level. If we need to, like, if we won't use used array and handle this using only for loop, um, let's say func for func. So at the same level, we can make this comparison using prev and current. All right, and here, if prev is equal to current, we can skip it, so we don't make call basically. All right, how about the next level? For next level, although we increase the start, all right guys, all right, I think we don't even need to use array at all. Like, we can make this duplicate comparison using like a prev and current basically at the same level. And for between the levels, we already increase start point. Oh my gosh, this is quite smart. So basically guys, uh we don't like like we don't even need to use this array. But here, what instead what we need to have is a mechanism. All right, same level elimination is this, but maybe we can compare, I mean, like a prev. But what is prev, you know mm, how should we, like, what is prev, by the way? At the same level, we need to compare current one, actually current one with the next one, not prev. So like we have input array, and if start is equal to input array, I mean start plus 1, all right? if they are same, like we should only, I mean, we should skip the next index, obviously. All right. And to do that, like like after making our operations, all right, copy this part, and after, so maybe guys, like we can append, all right, um but appending is, or I don't know, not like, let's bring them back. If the next character is same, basically guys, like do this, all right, do the same thing here, and then increase I by one, basic. This is what I'm trying to get, all right. Increase the um, I by one, so that we won't uh, you know process the next one. But for calling for next level, we are still increasing our start point. So like here we already like increased I, and we do it again, so that here we pass that duplication, basically. So instead of using prev, we use current and then next. But not from, I mean, not to go into out of index error, we can add a if condition, if start plus one is smaller than. All right, I think I get it. Um, let me. I think now I get it. Um, I think we don't even need to use used array at all, because we can handle these duplicate detection at the same level, and um, eliminating correct input interval between the levels by using start index. For duplicate detection at the same level, we just can compare the current one with the next character, if there is one, and if they are same, we can increase I, like iterator of our for loop, by one, so to be basically skip it. All right, and this is for same level duplication, right? And so between the levels we already share the start, so our parent gives us where to start. um yeah, so that would it work? So basically guys, in these questions, like changing the start index is one way, using a used array is one way. So let's see how many different ways do we have. Like, because guys, because like here we used like a like we used start index for, actually guys, not like this is smart guys, this is quite smart. Why? Because guys, let me open the decision tree. Because um like at the same level, recognizing the duplicate is easy. All right, we can literally build different kind of ways. But between the levels, like the reason why we eliminate one is kind of same and different. All right. um so the reason why we eliminate is not because of duplicate, but instead we cannot just use the same character multiple times. It is not about duplication. All right. Or you can say that using same character twice, more than once, would mean duplication, so that similar. But Obviously, like the move here and here is kind of different. Um, and for this between level elimination, we basically share this start index plus one. All right. But, but what I thought was, using arrays, used arrays. I think we can still use um, we can still use used array for duplicate recognition. Yeah, I think we can still do that. All right, let's see. Stop. Oh my gosh. Stop. Read your own word against your. You said if they are same, we skip it. Now look at when input array is true, what does the body actually do? Hmm. Let's see. Like it is my code. So if they are same, oh, we basically. Oh, sorry guys. So remove that part. If they are same, we basically. What should we do? To be honest. Um. Yeah, actually, this is correct. If they are same. Hmm. Like. Oh my gosh. I think I forgot why I didn't understand in the last step. Last thing we tried. I think for the same level duplicate recognition, we need to use used array, but for between levels, you updating the start index is enough. Oh my gosh. I tried duplicate. If there is a duplication, we need to process the first one, but not the second one. But I totally understand your point because imagine we have um, multiple duplicates. What I mean is that let's say number three, the number of occurrence of number three, let's say it is five. Five times it exists, all right? Let's say three, 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 three. So my code, like instead of eliminating all the duplicates at the same level, it only eliminates two times or three times, right? Um, but now, like, are you saying that for the same level duplicate elimination, we need to use used array, but between levels, we need to use um, like updating start index is enough? Like, are you saying that? Oh my gosh, guys, come on. We need to take a break. It should allow us. What were we discussing, guys? I genuinely forgot actually. Um, I think start index like wasn't enough. Direct answer to your question: no, you don't need to. Interesting. Redeemed rosemary oil sniff. All right, so thank you for that. Now I need some I need some brain cells to activate it to be activated, and smelling this helps me a lot. So thank you. Um, direct answer your question. All right. No, you don't need to. All right. So we need to handle start index both for you know the same level duplicate elimination and across levels. So now I tried using start index. For loop for detecting the duplicate at the same level, but we have failed basically. Now the thing we need to fix is that how can we eliminate duplication at the same level using this variable for loop correctly? All right. Maybe using a flag or something, you know, maybe before here, I mean some sort of flag, all right? And if they are same and flag is 0, then do this, and also make flag equal to 1. So all right. So mm, so oh my gosh. So basically, we need a state for if they are not same, and when they are not same, we should make this part again. uh, so maybe instead of checking if they are equal, maybe we can add a guard if they are equal. So if the flag is 1, meaning, oh, we need somewhere else to set flags to 0 again, basically. So what I'm trying to do is that, let's say we have duplicates, let's say 333, all right? For we need to make them into 1 3, basically. Let's see. Here's the structural flip you are missing. In every backtracking node, the default action is always the same 3 moves. Yeah, should run for every choice I. It is not something you do only when you spot a duplicate. Duplicate will only jump. Oh my gosh, I give up. Give me the code right now. I want to solve other questions, man. Come on. Which line is continue? Which line is continue, God? Oh, I don't know. Like my brain stopped working, so just show me the code and done with it. All right. So we have our for loop. All right. Yeah. So this is the magic. This is the part. So if all right. All right. If I is bigger than start, and if they are same, right now, don't rush. So like I'm hungry. I need to have my breakfast right now. So all right. So like imagine, guys, imagine we have, let's say, like a 3 3 3 3. So let's say our input are this kind of this order. Our input is kind of like this. So we need to basically eliminate all these parts. Alright. For it, the the approach we use is our for loop, and we basically compare the current one with the next one. But for the first time, we should process this. So this is why we have this flag, and this is why this comes first, right? Because if I is equal to start, we should process. All right, so oh my gosh, this is good. This is good. This is actually from arrays part, right? Like this is not about recursion. This is not about backtracking. But how do you eliminate? Like how do you process the first number, but the not duplicate, the next duplicate ones, basically. Um, yeah. Here, let's say start is 1, all right? Here, and we basically checking for like a we are checking this condition. If start is bigger, start is bigger than what? I, not start. I is bigger than start. Start value comes from our function parameter. All right. I is set to start at first and then increased by one. So for the first iteration, they are equal. So we don't go into this if statement. All right. But for the subsequent calls, and if the you know if these like a current one and the next one are same, we should skip it basically. All right, this is the way. This is the way, guys. Let me take a screenshot. So this is how we process for ones, but we don't process for the subsequent ones. Uh, Using this basic if statement, even though it may seem basic, like it is a logic. All right. So before going, I wanna see our next question, which is permutations. Which is a question that I have already solved, so that I skip and permutation. Let's skip that too. Combination sum. Mm, and we have combination sum too. And combinations. Oh my gosh. All right. So maybe we can continue with combination sum, but also need to fix this scene changing thing. So uh yeah. So all right. We can solve this. We can solve this. It seems fun. Oh my gosh, guys. I hate not being able to solve these questions. I mean, in previous question, like it is strange that we've spent this much of time, but the idea is easy. We don't need to use used array. We need to like but like we use in this index of 4 like iteration variable of 4, but here we had two different elimination strategies, one for at the same level and for duplicates, and between the levels by changing by transferring this knowledge. So this is why this question is listed under pre-order. We basically carry down this knowledge. uh like I didn't think this approach would help me for eliminating the already picked characters, but it really helps. So all right, maybe another battle, another day. Permissions too, or a combination sum. We're gonna continue with this one. Let me use my wonderful Pomo pause. I think yes, it is pause. Now we should. I mean, I should toggle off this feature. Which feature? Add. Alright. So we have a feature of mm, like a changing scenes during breaks, but I don't want it anymore. Can you fix it, please? So while I am live and when it is time for break, just don't switch scenes. Let's see, guys. And also maybe I can. Oh my gosh, still we are using Wi-Fi. All right. All right, guys. After fixing this issue, we're gonna have a break. Oh, I think I described it wrongly. The thing I wanted to, tell you is that ad break, not normal break, but ad break, Oh my gosh. So, Americano, my previous projects are just for vibe coded, one group project, no individual. What do you mean? My previous projects are just for vibe coded, one group project, no individual. What do you mean by one group project, no individual? So, are you talking about your college, perm projects, and you used AI heavily? Which projects are you talking about? Kinda, yeah. I see, I see. So, like, I don't know how would it be like if we had AI during college. Like, I don't know, because you could use AI to complete almost all of your homework. So, like, homeworks are kind of meaningless, but it may help you when your midterm exam and final exams, come basically. All right. Because if you learn it, you can get high score during those exams. But if you only, copy and paste basically, then it will it, it will be hard. It can be hard for you in the exam, face-to-face exams. By the way, I am live right now, so don't break anything. I just recently wanted to start actually making my own project. Before that, I was just copy and paste my. I see, I see. Yeah, yeah. Everyone was like that. Yeah, yeah. Like, AI opens so much opportunities actually. Like, I'm using it for learning. I'm using it for building, as you see. I mean, in our previous streams. So it is now much better than, 2 years, 3 years before. You don't need to, copy paste from anywhere. You can ask your question and apply it. It is privilege. Like, it should be in this way, even. All right. Um, I know that you are live. I'm not touching anything or nothing. No restart. Actually, I need you to change the behavior, all right? Because I don't want my OBS to change scenes when during ad breaks, actually. Before like taking break, I just want to, handle this, guys, and then we can take a break. Actually, 18 minutes. while it is doing its job, let me read the question. So we have this combination sum. So we need to find all the combinations that sums up to that target. Um, like I know it's two pointers answer, but now we need to do it in backtracking and pre-order. So we have our options like a 2, 3, 6, 7. So in each level, guys, we have the all of these options in our hands. So after making each choice, all right, we should compare it if we have reached, I mean, uh, to target. But the thing is, we also have a way for deciding that it is a new combination, basically. For example, we have like, can our candidates same like a duplicate? First, we should look at it. Are distinct? Yes. So if like I love this, all right, like you think something and you find that constraint in here. So if they are distinct, so there is no problem. If they are distinct, it is so I don't need to worry about eliminating these duplicates. All right. So in each after each choice, basically, guys, we should compare it with our target if they are same or not. All right. And let's say we have four options, and can I use the same option again? And yes, answer is yes. So basically, guys, in each level I have like a four options again and again. So this question is kind of easy. What I should do in each state is that like in maybe pre-orderly, guys, pre-orderly, we can check if we hit the target. All right. And you may ask, how do we exactly make a choice? All right. Uh, we can make a choice by subtracting the current choice from target. So basically, like a target minus, let me call choice. All right. This is how we make this. How this is how we explore this or make this choice basically. So imagine we have our function over here. All right. This is our function, and I think we have solid, guys. Let's say we have a for loop over here. mm, Evaluating every options choices C, all right, and let's call it C, all right. um so so even before the for loop, maybe, guys, like not like here but here, maybe we can add there our comparison, all right, checking that if we hit the target. How can we do that? So maybe the first argument should be uh, what should be our first target? Target should be zero, obviously. We should. Mm, oh yeah, we can compare it with zero, right? So if mm, we can call it value, right? It's a bad naming, but if value, I mean value is equal to zero, then we hit the target. Then we should add, all right, current result, current result to our global result, basically, all right. And also we should add some sort of base cases, all right, some control mechanisms. What I mean by that is, for example, we shouldn't be able to go beyond negative, all right. And Other than that, this question is quite easy. Because in each level you have all the options available for you, and all thing you need to do is like, maybe one thing you can do is, um like, after making a choice, guys, since we are sharing the reference of the same temporary array, after making a choice we should remove it so that we can make our new choice, obviously. So after making a choice, just remove um remove that option we have made. Remove, let's say, temp dot length minus 1, right? I think this is it. So let me so remove this part and type the real code, guys, here. So we will need these, I mean, temporary array. All right. And other, is this enough? But no, we need some sort of value, guys, to check with the target. Maybe we can, yeah, we can call it target, and when we call our function, we can call it using real target value. All right. Let's say integer target is actually 7, so we call our recursive function with 7. So all right, inside of our function, like, this is one, this is this, maybe we can remove that. So inside our function, uh let's start with for loop. All right, we should you know evaluate all of our choices. And where does where do our choices come from exactly, guys? From candidates. So we have on the candidates. We have our candidates, so maybe we should also, actually, we can have a global variable. All right, integer array candidates. How do we initialize an integer array, like a new int, and using this, right? um our candidates are 2, 3, 6, 7, 6 and 7. So we need to make a recursive call, basically. And our target, guys, will be this one. All right. And we can share our temp array, and then after making a choice, we should like remove that choice from guys, uh from our temp from our temp, basically. All right. So that in the same level we can make another choice. So imagine we are in the same level. All right, in the same for loop, we make a call. All right, we obviously make a choice, and we should remove that choice for the next iteration, because if we don't, then temporary will hold our previous choice. All right. So, and pre-orderly, guys, which is today's topic, pre-orderly. All right, pre-orderly, we also check if our target is equal to 0. Then it means that we should, I mean, we need another global list of list of I think integers, right? Answers. I don't know how to create, maybe array list. So we should like this is global result. Actually, we don't even need to write this comment because it is clear, right? So when we hit the answer, when we hit the target, we can just add our temp, I mean, add our temp to the results, all right? That's it, guys. And also another thing we need to check is if target, guys, let's see if my scene will change or not. I think it doesn't change. Wonderful. If target is below zero, guys, if it is below zero, guys, then we just return, all right? Yeah. So if we hit below zero, like there is no way we can make our new choices. So this is a dead end for us. So we should stop there and stop our recursive calling, and we shouldn't go any further. All right. Um. Yeah. So this is the answer, guys. So this was quite easy. This was quite easy. So let's copy this part. Um. Yeah. So copy this part and open our thing. Actually, yeah. Capture them into thought process and patterns MD and save it for today. We're gonna study our next question, which is what, guys? Combination sum. Um, combination. Perfecto. So now, guys, I think my scene didn't change, so which is awesome. Why, like during the break, like before taking a break, let's save the process, all right? Because now my AI is saving the thought process and the struggles that we had. I'll be going on a break first. Real hunger right now. Enjoy your food. All right. Take care. I will take a break now too, like maybe for 20 minutes or 15 minutes. I don't know. See you, Don Kinesin. Thank you. Thank you. Por favor. Por favor. Yeah. Привет. Por favor. What was the equivalent of thank you in French? Let's see. Uh, thank you in French. Merci, merci. Oh my gosh. It is, of course, merci. Merci beaucoup, Americano. Um, let's save the progress first. And then what is our next question? Merci de beaucoup. Bu butchered the spelling. Did I? Have I really? Merci. Merci. Oh my god. Just merci then. If I need to go save. Combination sum 2. So our next question is this. Let's open it. It got. So in combination sum 2, the difference is that given a collection of candidate numbers and a target number, find all unique combinations where candidate, yeah, each number in candidate may only once. All right. The solution set must not contain duplicate combination. So basically, they added like a recognition of duplicates on top of the combination. So some, I mean, since we know how we should handle the duplicates, which is using either a used array for the same level, or like using a for loop and basically compare current value with the next one and continue. And also between the level, like across the levels, by carrying down the start position, we can do this. So um, we can do this, guys. We can do this. All right. So now I think all right. Now we are ready to take a break. Now, like our files are ready, but in the next, like after the break, guys, we will continue with combination sum number two. All right. But I wonder what is the question after that? Again, some sort of combination. Oh my gosh, like combinations. Let's go. So let's see what sort of question is this. You given two integers, yeah. Return all possible combinations of k numbers. Choose, yeah. What is that? Like what is this, man? There are four choice to six total combinations. Note that combinations are unordered, are considered to be the same combination. Oh my gosh, one, two, one, three, and one, two, one, three, one, four. I think we can do this too, guys. But what are our options? Our options are from 1 to 4. So while our options are from from 1 to 4, we need some sort of decision tree that will generate this, guys. We can we can do this, guys. We can do this. Um but after the break. All right. Um so let's stop. All right. All right, see you after the break, guys. Um how many minutes? Maybe 20 minutes, guys. Set it to 20 and start break. Guys, hello, welcome back. Let's continue, right? We don't need, we don't even need a break. Like, I forgot exercising. Now I remember. I had my breakfast, but I'm quite excited, guys. I'm quite excited about, yes, the combination question, right? Yes, guys. Let's see. Let's see, guys. Let's see, all right? Um, yeah. So let's paste it and let's try solving it, all right? So it's gonna be fun, man. It's gonna be fun. So let's continue. Um, Let me take my pencil over here, guys. And so, guys, like the first thing we need to do is determining what our options are. Right? Our options, guys, if n is 4, our options are from, from 1 to 4, basically. All right? So this means that, guys, in each level, in each level, in each level, like we need to make these decisions, all right? But the thing we need to care about, like, let's focus on this part, guys. Let's focus on that. Look at it. Look, 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 look. The 1 2 1 3 1 4. All right. So it means that, guys, after making choice of one, all right, which is here, our remaining options are, I mean, we obviously can use a start index, all right, obviously. And we like as a parent one, it can give the start plus one, all right, as an argument, which is pre-order, like a 2 3 and 4, guys. So but look at 2. 2 has, I mean, 3 and 4. The interesting part is, guys, we don't have anything with 4. So but we're gonna figure that, all right? So for 2, guys, the options are 3 and 4. This, what was it again? 3 and 4. So we have like a 3 and 4 over here. I guess we have only 4 over here. And that's interesting, guys. The another thing we need to care about is that our level, guys, our level, I suppose, will be limited to k, because if k was, or were, I don't know, if k was 3, mm, actually the thing I need to understand is that, like, let me, like the thing I need to understand is that, is is the, I mean, is the length of every combination 2, or can it be bigger than 2? Actually, I decided to study this question, and my question here now is, like, is the every combination's length is 2, or or is it related to k? Like, if k was 3, then would we have outputs of length 3? So can you give examples with different n and k's, please? Like, I had this during, high school, but I forgot this permutation and combination thing. But let's see, like, it will be enough for me to see a few examples, all right? So let's, yes, as I said, as I guess, the k All right. So k shows us the number of elements. So this question is quite fun, actually, guys. This question is quite fun. All right, because the level. So now we need to think about how can we determine which level we are in, guys. So we can obviously do that by passing another parameter, all right? So with each call, guys, with each level, I mean, all right? Which and a call or level is kind of same, because as we make a call, we basically go into another level. So basically, guys, in our parameters, we have a parameter of level, all right? And this level shouldn't go. I mean, we should stop at k, all right? And we shouldn't go any further, and we should save the result like imagine having a temporary array, and after adding um after adding a temporary array, we should save it if we are at the correct level, and we should add it to our global result. Basically, we should store it in our global um, result. But the thing is, maybe the saving operation, like since we are applying pre-order, like we can go one step further. Anyway, we can um, think of this detail later, because what I mean is that like something should trigger saving operation, all right? Where is it gonna exactly be, all right? Where is it gonna be exactly? Yes, I suppose when it becomes k, it becomes 3 if k was 2, and if it becomes 3, then we can understand that we should save the temporary array to our global. And also we don't continue any further than that. All right. So um so imagine having a function, all right, like this one, and let's focus on this number, like a choice cell. So at first level we have every every option, but actually, guys, hmm we have every option. Yes, we have every option at level first, level 1, but we don't save it immediately, right? So the where we save is that at the k level. All right, this is important. So at first level we have our all options, which is amazing, and we have obviously our temporary array, and as we go one level further, our options are limited, or are starting from start +1. So we basically should also um, share this parameter, all right? And we should share it with start +1, so that in the next level the for loop will start this. So yes, so if let's say I is 1 here, and here I starts from 2. Yeah, in this level. Yeah, amazing. So this is it. And for saving the result in our like a if statement, or we should have an if statement or something, and we can start k at 0. We can start k at 0, and when um I mean I mean maybe we can have a variable like a called k, like a k can start from 2 apparently, and 2 1 makes 2 times, and when it hits 0, when it hits 0, it means that we are done, and we can save the temporary array to our global. So we should basically save temp to global if it is 0 and return basically. All right, this is it, guys. I think we have solved it, and but we didn't talk about level. Yes, so like actually this k should be k minus 1. As we go one level deeper, we should decrease it. So I think, guys, this is the solution, and it's gonna run perfectly. All right, so let me remove this part over here, and let me type it, guys. Let me type it. So let's say um void and func. All right, and we have our for loop. All right, and our choices. Where do our choices come from? I think from n. So we have, all right, our arguments are these. Let's put them in. So from, I think from, yes, from not 0, but it should be start. All right, and like imagine we have start parameter 2. Forget about the lead code version. So we have start, and we call our function. All right, let's say 4 2, and start is 0. All right, start is 0. So integer I starts from 0. um it should be smaller than I don't know what, and then it increases. All right, so here we have, like, now we should call start plus 1. So start plus 1, yes, and then we should decrease the k by 1. All right, and then the n can stay same basically. And we also, like, we need also a temporary array, obviously. And for temporary array, I guess we are using like this one called a temp. We should also have a global, like a global list of integers. Okay, let's call it result. All right, this is same for every question basically, guys. This is same. And when we hit the, not maybe, like, when we hit the correct level, all right, when we hit the correct level, which is here, we should save our temporary array, because we have like a 1 2 1 3 1 4. Yes, like here, like at these leaf nodes, we should save the result and stop recursing. And uh where yeah, so if k is equal to 0, guys, we should save we should save our temporary array basically. And also, guys, imagine, like we have, like, let's say we make this choice. All right, and then when this choice returns, all right, um when it returns, which is here, guys, when it returns. All right, when it returns, and then do the for loop again, we should clearly, I mean, remove the last element it has. All right, we should do it so that when it returns, and when it tries to make another make another choice, our temporary doesn't have the first choice. All right, that's why we do this. So this is pre-order part. In during pre-order, should we do anything at all, guys? And this can be, guys, can n, right? No, n plus one. Like this is important too. Like because here, yes, yes, n plus one, n plus one, n plus one, because you know, uh, like we are evaluating zero, not zero. So start is, guys, basically one, and I goes to n plus one, because we should process four, like a one, two, three, four. So we start from one, and we go to until smaller than five, which is four. But now I'm thinking that what should we like? Is there something we need to do in in pre-order? Yes, obviously, because we should add this element, obviously. Like I didn't think of it right away because we um oh we even don't share the temporary array. So n k start and then temporary. All right. So that's why I didn't think of it. So we need to share the reference of it, and in that reference we should have the current choice basically. And how do we get that? Uh, how do we get it, guys? Where is our current option? Um, Actually, our current option is, guys, I itself. So basically, we add I. So this is our option. We add it. We create a new world, like a new stack frame, and in that stack frame, we start our start. Start from start plus one, and we decrease the k because as we go down, guys, as we go down, our goal is like hitting this and saving. So k is used for level recognition, basically level recognition. We recognize which level we are in, and as we make a call, it means that we are one level deeper. So we have our beautiful, amazing base case. We have our amazing, wonderful, significant for loop. All right. And our options are like, is this correct, guys? Like, like here, for example, yes, it seems correct, guys. It seems correct. But the thing, yeah, no, like here, the I, like I one, like I is four basically, and I is four, and it's not gonna be able to make another call, right? Because I is four, yes. So it's mm, actually, guys, I was four, and it will try creating another, like making a call with five, literally five, and here k is not zero, but here, since like it will start from five, but it is not smaller than this, so it will stop. So basically, this node is gonna create, like is gonna, yes, it definitely create a five, but it won't be able to save temporary to our global or something, because this is gonna be created. But that is all right because our for loop prevents you know it to go into this one, so that the recursion in that branch will stop. um all right, all right, all right, all right. So this same rule applies these nodes too. So we have 3 and 4, which is like the answer is 3 and 4. At 4, it's gonna try another call, and in that call k will be 0, like will be equal to 0, and it will try adding the temporary. So this is the answer, guys. If we copy, all right, if we copy and paste it again, paste it exactly, we expect it to, actually we need to return the result. So it asks, like it wants us to return that thing. So maybe we can create a globe. Actually we cannot run it here. So maybe I just should copy this one and open the question on this one. Lead code combinations, por favor. Uh, so yes, so I can just paste it over here. So these are global value. These are actually instead, all right. So we can call our function instead of this one. So let's call our function using n k. What is start? Start is 1 and temporary array. So we can create a temporary array just like this. And we can give its reference to here. And this function doesn't return anything. So, but when it hits 0, it adds its answer to global result, which is awesome. And this, like, I think this is gonna work and we're gonna be happy. Let's see. Oh my gosh. Oh my gosh. Oh my gosh. The and compile error, guys. All right. So this is um why. Hold on a second. This is an easy like so we have like we I. All right. So forget about this compile error. Uh, and like what is that? Illegal start of expression. What mm, what am I doing wrong? Like this stuff. Maybe not like this, but this no. A new. We forget to put the new keyword, guys. Come on, like this doesn't count either. Let's run it and hope for the best, guys. All right, and not integer, but integer, guys. Like this doesn't count either. um. Oh my gosh. So we are adding. Yeah, like this should be correct. So we are literally adding temporary to the result, but it says that all right. So this doesn't cut either, guys, because we used wrong argument name. So this doesn't count. So let me also actually I can type Palmo resume and it's gonna be just fine. And another thing, we have all right. This doesn't count either, guys. Like I guess I don't see it today. I don't see anything. But now, oh my gosh, come on, man. Like a result, this is method, this is method, this is class, and it we should return. All right. Oh my guys. Like, I just want to see the result as soon as possible. That's why we are getting these silly compile time errors. But it's gonna be just fine. It is not fine. Oh my gosh. I can explain this, guys. Um, so at least the number of answers, like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess, guys, I guess I see it because it is 2 times of the number of elements that is expected to be here. So the issue is that, guys, Oh my gosh, guys. The issue is that we, we guys, we are gonna solve this issue. Like, like we don't see anything in our output. So, like when we hit K, yeah, we are decreasing the K1 like by one. Hey, CEO, Sona Tornet. Oh my gosh, welcome, welcome, welcome. Por favor, merci beaucoup. Stream Arena. Oh my gosh, let's activate the Stream Arena too. Uh, where was it? Let me find it. Uh, it was not this one, but I guess this one. Let me open that project, bro, and stream. Yes, this one I think, and here. Let me. Actually, we can open here. I think we can open here too, guys. So like, and host, and the host key is, guys. Um, we don't. Didn't I paste the host key right here? So can you give me the host key, please? Like I thought I pasted here. Hold on, Americano. We're gonna handle this. We're gonna find our host key. Yes. Um, it is here. Let's save it so that next time it will be easy. And the room code is this one, guys. And you can reach the arena at this address and type your code, and we can, co-work like a pair programming. You are welcomed to, come here. Um, what were we doing again, guys? I totally forget. So I guess we were here. No, we were. All right, thanks. Come on, come on. Where are you? I don't see it. Come on, waiting for players to join. So we were getting some silly errors because, I mean, not this one, because like as we hit K0, we should save the result. But the result we are saving, maybe, guys, instead of like this is literally the last item. So we add an item, we make a call, all right? Like this should work, guys. This should work. Why doesn't it work? Like even the output is too ugly. Look at it. Like actually, the thing might be, guys. No, actually, like we already thought about it. So if K, like actually, what is the case? Yes, K is 2. So if K is 2 at level 3, all right, um, we hit like a K is 0. I mean, K is 0 condition basically, all right, and we immediately save the temporary we have. So what temporary we have at this here? Like here we have like a one. I mean 1 2. All right. Like here we have 1 2. All right. Um, how do we call it again, guys? Oh my gosh. So we add 2 and we call it we call. So we have now 1 2 in our temporary. And what is start? I think, guys, because of this, like we don't even call here, all right? Because like we start, I mean, we start from one, all right? Maybe this might be the problem. What would happen if we just change it to zero? But there was a reason why we started k. I mean, yeah, there's a reason why we start from zero one. Oh my gosh, let's run it, guys. Oh my gosh, like this is even worse. So it should be definitely one. So now we need to find the error we are making. Let's look at the stream arena and Americana here. Hello, yes, hello, Americano. Can you see me? Yeah, but but the thing is, we can type the exact position, right? We cannot type different positions. This might be a so like let's see. No, hold on a second. Hold on a second. Like I'm trying to create a for loop, all right, and I can leave it like I can leave the creation of for loop to you, I guess. While doing that, I thought that like I would have my own, thing, but let's see. All right. Now, as you said before, as you asked before, Americano, now at least multiple people can work on the same, like a host and the, contestant can work at the same. No, I have my own, I think, right? Yes, yes, I have my own. I have my own cursor, I think. Can you type while I am typing? Please type. Oh my gosh, that is wonderful, man. That is just wonderful. Amazing. Por favor, merci, 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 merci. Crazy. Yeah, yeah, yeah. This is just wonderful. Like this is good, man. We need to solve a lot of a lot of lead code problems this way. Copy paste. So like the the thing is that, guys, jokes aside, uh my code is failing right now. We need to debug this. Help me debug this. So the the error, like we literally add our current result temporary, and then um optimal lavoro. Optimal lavoro. What does it mean? What does it mean? Oh my gosh. Um, so like we add our current result to temporary and make a call. And when we hit base case, we literally save it to uh global, but in like this temp thing is empty. Like how on earth this is possible? Like this shouldn't be possible. Like we have temporary array, we literally add it, so like this shouldn't. Oh my gosh, why? Like, what am I missing, guys? Like, I'm really triggered, right? We have, let's draw the decision tree again, but this time with color green. So we have our four options, right? We have our four options, and here our options are, 2, 3, 4. All right, one less compared to parent. And when we try to call again, we shouldn't be able to, because if we call this function k equal to 2, um, when we make our first call, we call with, like a k minus 1, so it is 1, and here k is 0. Here k is 0. That is interesting. So maybe, guys, the answer is that we can just start our k not from k but k minus plus 1, and then problem is solved, as we will see, as we don't see. Oh my gosh. So we start k from 2 basically. All right, here k is 1, and for example here, um like, what was the output again? 1 1 2 1 3 1 4 2 3 4. So basically 3 and 4, 3 and 4, 3 and 4, 4, and for 3 it is 4, right? Yes. And we don't have anything for 4. And every call at this level, we don't have, like, we don't do anything, all right? I mean, at this, leaf nodes, we don't know anything about it. Like here k is, equal to 2. Like, imagine the call, all right? So k is 2. Inside of it we have a for loop, all right? And inside it we are calling our function with k minus 1. So here k is minus 1, and our options, in our for loop choices, we have all of our choices. We add them in our temporary array, but the thing is, like, we don't we don't have this in result, because this doesn't have here, all right? Because length, I mean, yes, actually it tries, like, it creates this node, but with 5. So we need to care about this later, um because here k is 0 2. Maybe we should check if, like, a, I don't know, like, it is silly, but how about -1? I don't know, man. Again, oh my gosh. So, like, the issue is that we don't have anything in our temporal array, and, like, are we doing something wrong? Like, we literally add this number, and where at this number, all right? Yes. Lots of red. uh my neck hurts. Oh my gosh, I'm sacrificing too much on this, guys. Anyway, Without sacrifice, you don't earn anything, right? Um, like it would be great if we see some sort of, uh, rosemary oil in it. It would be great if we see like a even even single correct answer, guys. We don't have anything in our output, and like I don't know, guys. I don't know. Like we, oh my gosh, oh my gosh. I hate it when this happens. Look at it, guys. As Americano once said, lots of red. But the I should debug this. I should definitely debug this. And like um actually actually we can debug this, but I had an I had an application, I remember, saying oh, Fenomeno. You still haven't taken a break? No, no, no. I like we've taken a break. We are good. We are good. We are good. Like 20 minutes long break we took. Uh, I'm quite better now, and we're gonna fix this. We're gonna fix this. Fix this. All right. All right. All right. Like if I were able to debug this, I would definitely solve this. So that's why I'm gonna copy this, and I'm gonna ask my beautiful AI to debug this actually. But of course, like in this way. Come on. So I wanna debug this, create a Java file somewhere appropriate, um, and add a system. Like I wanna be able to run a command to run this, see the output in the terminal. So, and I wanna see my temporary arrays. All right. Uh, so create such Java file. All right. You can create it in our basically debug folder here. What do we have in these lines? Oh, the code, right? Oh my gosh, I even forget. I'm even forgetting what I have done 2 seconds ago. But this is alright. This is alright. We're gonna debug this very bad, very badly, and we're gonna see what is wrong with it, because like the answer is clear, guys. Like we try every like actually we don't have for each, but normal for loop. All right. And we start our index to from start, and we share start as start plus one. All right. So that in the next level it starts from one step further. And when we hit when we hit k minus one, k equals minus one, then we save the result. But our temporary arrays are literally empty. So override. So all right. So we need to go, guys, into lead code. All right. I guess like this one, and then debug, and then run this one with parameters, I guess, and 4 and 2. Oh my gosh. And a j in the beginning. The final result. So let's see. Oh my gosh. How am I? How are we supposed to debug this, guys? So we start one. So our code, yeah, and we add like in our temporary array, guys. As we can see here, our temporary array holds amazing thing. And now let's look at it. Like we have like a 1 2 in our temporary array, which is you know spectacular. uh what's going on over here? Like, oh my gosh, in our temporary we have 1 2 3 guys. This shouldn't happen. How to remove the last character in array lists in Java? Like, am I doing something? List size -1. Like start is 1. We add temporary 1, and then another function call with start 2. Yes, k is 1 this time. We add 2. Yes. Now start is 3. Yeah, we have 4 elements. So yes, yes, we should add 3. Like this 1 2 3 is 1 2 3. So basically, I forgot. All right. This is all right. Like we have one level more in. Oh, if we have one level more, we shouldn't have one level more. So okay, 1 2. So maybe we should. Um. All right. So maybe, guys, the the mistake was with the k. We should start k, and now, guys, we have fixed it. No, we haven't. All right, guys. We have, in fact, not fixed it. Exactly, America. Like, I I I believed in myself. I believed in this solution. Uh, really. So guys, so k is minus. So I think we should like make this one, save it, guys. All right, like we're gonna fix it, guys. We're gonna fix it. Otherwise, world is gonna end. So we need to save the world. All right, and using this code, which is even worse now. World depends on us. We're not gonna let world go down. So we add 1 in our temporary array. We now k is 0. But the thing is, guys, let's look at the code, guys. Let's look at the code. So our wonderful, amazing code is this. We basically, like, by starting this I from this start, we basically, as we go into another level, and since we like use start as start +1, we eliminate left part of input, so that you know they start from one step further. So basically, we are doing this here. All right, instead of starting from 1, we start from 2. And here, since I is now 1, we start from 2. I is 2, we start from 3. 2 3. I is 3, we start from 4. I is 0 and we start but I is 1, we start from 2, like 2 index. I is 3, we start from 3. I is 3 and we start from 4. Yes, this is 4. I don't know, man. I don't know. What is this 5? If we start from 4, what is our for loops ending condition? Like we should look at this. Ending condition is n plus 1. What is n? What is n, guys? N is this, which is 4. So the reason why we do this is that, like, we start n from 1. This is what. Oh, all right, all right. We start not 0, but all right. Now let's fix it, guys. Let's fix it. Everything is just fine. We're gonna handle this. All right, all right. We start 1, so this starts from 2. We start from 2. This starts from 3. This starts from 3, 4, or whatever, and 4, and that's 5. But 5 is okay. No, is it okay? Is it not? It is not okay. And since it is 4, oh my gosh, I can't even. Anyway, we're gonna handle this. So 1. So we basically start from 1, right? I mean, yes, we are giving 1 as a start point, which is our third parameter. We start from 1, 1, 2, 3, 4. Yes, when it's 5, it doesn't go into this for loop, which is awesome. So there is nothing we can do. Hey, at this normal red, I don't know the meaning of it. The world is ending. There is nothing. No. Like we can save the world, man. Just trust in yourself. We can save the world. All right, we're gonna save the world after solving this question. I hope. Oh, so now, so now our for loop works. All right. Um, like, let's see. Um, let's see the output again. We start. So we start, from 1. We add 1. So we start from 1 and we add 1 because we literally add the indices of for loop. I mean, in the next recursive call, which is here, guys, which is here, start like I is 2, basically. We add I. We add I. All right. We add I. We add I. And in that call, the temporary is this. And then we make another call. We make another call, guys, here. So I guess, guys, the thing I didn't think of is like this level, because we should save the result from this level. Yeah, but as a base case, I used K, all right, and why on earth we are able to add this like a 3 into our temporary, and even more, what's going on over here, guys? Like a K is literally -1 here, all right. um like, it should stop, but it doesn't stop. Let's see the code again, please, guys. When K is 0, we literally add, but I hear like a -2, -3, like and also now the thing I wonder is why it's stopped. Why it has stopped? Like, only stopping point was K equal to 0, and then it should stop. But the thing is, now K is not even 0. Like we start k, like k is here. Oh, all right, it already said. So k is 0, and we add 1. I mean, result now has 1. Like it says the result has 1, but in the answer, why we don't see it? So maybe the problem is something else. Maybe it is because we added and we remove it, so we share. Oh, all right, all right. So the issue is that sharing the reference. All right, all right, all right. So um, we should create. We should basically um, I mean, how can we create another copy of array list? So let me look at it. How can I create copy of an array list? Like in Java. So, but this is one error, but we also should original list, new array list, like this one, and the original is temp. So now problem is solved. Not solved fully, but oh, maybe we should just give this one and run it again, guys. I think yes. Now we see our results. We need to now fix it. We have 1 2 1 3 1 4. So at least our level is correct. We have like our all of our length of our all result is 2, which is amazing. Like 1 2 1 3 1 4 is okay. 2 2 2 3. I think, like, do we have 2 4 here, guys? Yes, we have it. Like a 1 2 1. So yes, I think we have 1 1. No. Yes, this is correct. 2 2 2 3. We have 2 2 again. So we should get rid of this. All right, we can do that, I suppose. Like these are correct. And then, guys, we should only have 3 4, and we shouldn't have anything starting with 4. All right. All right, we are getting closer. We are getting closer. So now that we know we are getting count 12. 1 2 3 4 5 6. Yes. Um like where are our nodes? So we should paste it. So, and the correct answer is this one, which is 6. All right. Now we should, I mean, our decision tree looks correct, but maybe we have something wrong with, I don't know what. So these are our options. These are our options. 1 at first level. 2 3 4. All right. All right. So we want like a arrays with length 2, which is amazing. Oh, so no backtracking. It needs to be optimistic and only look forward into future. No, we are applying backtracking actually. Here, as we remove, we literally backtrack. It needs to be optimistic and only only look forward into the future. Like I didn't fully get it, Americano. But let me draw the decision tree again and try detecting colpa mia. All right. So, um, like, is it Spanish or Italian? I suppose Spanish, right? Right. We have our options. This is what we get, and this is what we're supposed to get. Yeah. Italian. Oh, that's nice. That's nice. Um, so buongiorno. Buongiorno. Nunca habla español. I think you said that I cannot speak español or something. Which is the spelling. But man, making mistakes is a good one, right? To learn. So guys, we have this one correct, or all this one is correct, this one is correct, this one is correct, but this one is not. This one is not. This one is definitely not. And these are all wrong, guys. So if we fix it, we're gonna save the world. So this means that, guys, we correctly use our start index position increment as we go one level down. All right, because like these answers are correct, and they literally tell us that picking the next character is correct. But the thing is, but if they are correct, then why we don't like we shouldn't have this at all, because this is 2 and its index, I mean, its index is 2, all right, and we increment it. So we shouldn't have this. Like, how on earth we have 2 2? Like, we should debug this. We shouldn't have this, because we literally call our function with start plus 1. So we shouldn't have this. So let's look at the code, and let's look at uh, and actually another thing I wonder is, why do we have this? Why do we have this? Anyway, we can focus on this later, but the more important thing is that where do we exactly have this 2 2? Oh my gosh. 2. Where is it, guys? Where is it? Where are you? You can hide, but you cannot escape, right? Yes, 2 2. So k is 0, which is awesome. Like, start is 2, and in our temporary array we have 2. You can hide but not escape. Super Ventus. Oh, I didn't know it. I didn't know who the author of this code, or the owner of this code. Like, we have 2 in our temporary array. Like, literally what this says is that we have, oh my god, like start is 2, and we have, like, we can have 2 in our temporary array, because we should have, I mean, alright, we should have it, because we literally have this here in our temporary. We have this, but their start shouldn't be 2. That is strange, man. Um, like start should be 3, guys. Uh, so let's look at the code again, please. Oh, so we literally call start +1, but somehow, like in our temporary, we have 2, and we add 2 again. Like we increase it. Like this shouldn't happen. This shouldn't happen. So like another thing is that I thought that we literally stop our recursive call here. I guess this, like, let's add this too. All right, let's k is smaller than 0, and and save it and see it. All right, like this wouldn't change the two k's, but at least I don't want to see like a 4 number of. Oh my gosh. Result now has, like, what does it mean? Result now has a result. Result size. All right, so this is the number. All right, so this has nothing to do with that one. But the thing is, oh, sorry, we shouldn't. I think we need another base case where if k is smaller than 0, we just return, man. All right, this is what I wanted to do. Let's try it again. Oh my god, where are you? Run it again, and guys, at least I don't see like a 4 number of temporary arrays, but I didn't like I even don't want to see like a length of 3 temporary arrays, because what I want to do is literally stop recursing at level 2. But the thing is, we can't, because our stopping point is increment by 1 again, and then here check. But yeah, so we check like here. Yeah, so here we check, we add the result, like the temporary. So that temporary should oh my gosh. So maybe I just should drink some water and think about the decisions I made in my life for a second. Like the thing. And rosemary oil sniff. Thank you for that. Let's smell this amazing smell, Like I tried, tasting it, but it doesn't taste good. But the smell is good. I have too much point. Thank you. Thank you. Um, so let's put it here. Maybe yes, here. So the thing is, guys. All right, I just should pick one thing and fix that. So let's look at the logs over here. All right. So we basically start with 1, k is 2, 10 more rosemary. No, like maybe after 10 minutes. Thank you. I should create more creative stuff, so that you can spend, maybe, I don't know, like stretching or something. Um, we're gonna figure that. Che Paura. Buongiorno, buongiorno. Like we start. Oh my god! Start one. We literally add one. So this is per order. Like this is per order, and then we recursively. Actually, instead of enter, instead of enter. All right. I'm gonna see it better. So we call our function 100,000 points. Answer my assignment. Yeah, we can do stuff like that. So let's see how well you are doing, Americano. What are you doing? Yeah, I don't see any code over here. I have my own. Yeah, so come on, pick a challenge and let me see your code, man. Um, made nothing new. Didn't know what to do. Alright, alright. So, uh, haven't opened lead code yet. I see, I see. What you can do, you can watch me and try help me like debugging this code, basically, alright? So we call we call our first call with start one, k equal to 0, and temporary is empty. Alright, which is awesome. I'm watching just not alright, alright. We're gonna handle this. We're gonna handle this. So this is our first call. Like this is literally um this call, alright? The thing we see here. Alright. So now we add one. We add one. Let's see. In our code, we add alright, so literally here we add the first like a start, alright. Our temporary, so now temporary becomes this one, and then we make a recursive call, alright. Um alright. Now start is 2, which because we increase it, yes. K is 1 because we decrease it, yes, to recognize which level we are in. And uh here we were at level 1, like first level, and then here we have like we are at level 2. But for us to be able to recognize we are level 2, we make another call at level 3. At level 3, but at level 3 our temporary is 1 2, and we literally we literally add this into our global result. Like we have found it. Like we were saying that we have found an answer. So forget about this part. No. Yeah. Just yes. Backtrack, yes. So just forget about this part. We literally add 1 2. So and that's alright. And we continue. We backtrack. So we have 1, and now we're gonna yes. So we add 3, and we save it. Which is awesome, which is amazing. Now we backtrack. We try for 1, say 1 4. Um, so we save it to our global result. All right. Now our temporary array, guys, is empty. All right. So this means that um, we basically complete this subtree, and then this returned. All right. And now this temporary is empty, and we add 2. All right, which is awesome. We are getting closer, guys. We are getting closer to save the world. Now temporary is empty. Temporary. So we add 2. Um, yes, this is what we need to fix. Like we literally have empty array. We add 2 and make a call. Oh, I think I kinda I kinda see it. I kinda see it, guys. I kinda see it. No, I don't see it. I don't see it, guys. Like like we literally finish where I is equal to 1. After it finished, we cleared the temporary, and then at 2, yes, and then somehow I don't know how, when we call this function, it adds 2 again. But in the next iteration, start is increased by 1. Why make I equals to that, not just use I? It is because this. Um, Imagine we are at here, all right? When we call, like when we go deeper, when we go one level deep, we shouldn't start from 1 again, but 2, all right? Like at first level, we start from 1, 1, 2, 3, 4. At second level, for this node, we should start from 2. And here, for this node, we should start from 3. So 1 increment, all right? Because at each level we have 1, 2, 3, 4 as an option, but as a choice, but we need to limit our options correctly so that our algorithm does its work correctly. So that's why we share this information on the way down. Capito. All right. But the thing is, but yes, Americano, look at this, all right? Buongiorno. We are doing this here successfully, but we cannot do it, like, if we are not doing it successfully here. Like I is literally 2, but in the code somehow there is, like, it creates 2 here again, and it adds like a 2. But we literally make like a start from 3, like a 2 plus 1. But it seems that it doesn't add. Like, this struggles me, this confuses me. Like, I shouldn't see uh where was it again? Oh my gosh, I should have saved. So I shouldn't, yes, so here I shouldn't see this one, all right? Like start is 2. Like here, in the next iteration, yes, in the next iteration it is 2. We add 2 in our temporary array, and you are telling me that you are adding one once more. Buongiorno. Also, is this the code in the stream arena? Is this the code? Yes, yes, it is. Yeah. Yes. So I need to fix this issue. Oh my gosh, man. Uh like, how many minutes it's been? Oh my gosh, we didn't. I think we can, like, I mean, after maybe 10 minutes we can take a break. So the thing I wonder is, like, after function we add it. After that, this is our function call. This is our function call. We literally call our function with, yes, because we add it. We add it and then call. But in that call we are adding it again. But in that call we shouldn't add, because, like, why am I seeing this one? I literally don't understand this part. But is everything fully correct? Is everything completely correct in the previous step? Let's start from over. Start is 1, k is 2. So we add 1 into our temporary array. And let's look at it. Let's look at it. After adding 1, our next function call starts 1 by 1 increment, 1 further, 1 increment, which makes it add the next character. And then in our next function call, it is 3, and we cannot add it. Yes, we cannot add it, as you can see, because k is the 0. Yes, yes, this is, we can forget about this part. It is nested and last leaf node. It's not important. We backtrack 1. We backtrack, all right, to 1. All right. We all right. Have we? So we added. So yeah, anyway. So we basically remove the last character. All right, all right. So now here start is 3. This is, we are at level 2. So we are at level 2, and here, all right, here. So we literally add 2, 3, and also we should add 4, 2. Yes, we add 4. This is leaf node, and now again we start with 2. Like, oh my gosh, this is, here again I don't understand it. I don't understand it, why we are adding 2 again. So basically, after these returns, it clears itself, and we add 2, and we make a call. Basically, we add 2. Yes, we are making a call with the temporary we add, and we make a call, and in that call start is 2. Like, I think this is the issue. In that call, it should be 3. Like, we should see 3 here, but we see 2. Like, this is the issue we need to fix. And why it is 2? Like, we add, I mean, like, we have our function, all right? Like, we have our function, our for loop, and our function again. And when our parent is 2, which start value we are giving to child? Yeah, we literally give the start +1. Come on, man. Oh my gosh, I don't know, guys. I'm gonna take I don't know, 15 minutes break, and I'm gonna ask it. So I cannot find it, so I'm gonna ask it. This is like, I don't want to see like this one, like this start should, like, this is the error, but let's see. All right, 15 minutes break. Oh, focus, break. All right, bye bye. Hello guys, hello, welcome back. Now I realize that the silly mistake I'm making, all right? Guys, here in this for loop, like start is the like of argument, all right? We are getting. But we should give the parameter of for loop, all right? This was the silly mistake. Now let's see how well. That was quick. Yes, that was quick because like almost like in 10 seconds I figured what I was doing wrong. And yes, guys, here we are. We saved the world. You don't need to thank me and my amazing friend here, Americano. Buongiorno, por favor. So we've done it, guys. We've done it. Um, so let's open the which one? I think this one, and let's change this silly mistake and run it again. Oh, I was right, but for the wrong reason. See, Chibufo. Oh my gosh, why it says wrong answer? We have find the correct answer. Oh my gosh, I think it's because there are some other places. Oh my gosh, this case the code. Um, check check the code we have here. Um, okay, K is one. Yeah, it should be fine. What happened? What is going on? We saved the world, but now we need to prove uh, that we save. So here again, we are getting empty. So what was the issue with that? Like getting, I guess about this K. Yeah, about this one. I think um when it's zero, and also like we should also create another temporary, because if we share the reference, then um let me copy this part first and then you know paste it over here, and then instead of adding the reference of it, like this is another silly mistake, we should you know create a new instance, and let's run it and let's prove the world that we have saved them. Yes, and now let's submit it and take a deep breath. All right. Please. Oh my gosh, it is accepted. Finally, guys, finally. Don't look at these numbers. I don't care much about them. We internalized the pre-order traversal. We created our decision tree. We applied post-order, pre-order. Like this question was easy actually. This was quite easy, right? Um, but now it is better. Now it is better. Compliment. Thank you. Com- complimentary to you too, man. So now our next question is, guys, not combinations, but you get it right. Letter combinations of a phone number. I've solved this question, let's say 3 years ago, or I don't know, maybe 2 or 3 years ago. Let's solve it again, and now we're gonna. Oh my gosh, we're gonna like this looks terrible. All right, guys, this looks terrible, but actually like yes, 3 years ago. Now I'm gonna face this very problem again. All right, again. And I'm gonna like we're gonna crash it. All right. uh yes, we're gonna definitely crash it. It is now revenge time, guys. It is now revenge time. All right, it's time for revenge. I struggled understanding this question very much, and now we're gonna beat it up. All right. Should I time for it's time for a show? Yeah, it would be it would be nice. It would be nice, but I wouldn't need like a 45 minutes, all right? Because I'm gonna crash this in let's say 20 minutes at most, at most. Um, let's see. Um, um, 20 minutes. No, man, it was a joke. Come on, man. You don't understand any joke. It was a joke. Um, yeah, yeah. We're gonna handle. We're gonna crash this. We're gonna crash this. So, what I need to think about is that, like, what are my options? My options are, I guess we have some constraint that digits range between 2 and 9, indicating like a 2 and 9, so we don't worry about these buttons. 30 minutes, buona fortuna, ti servia, ahaha. So, like, we don't care about these buttons. So 2 to 9 is so. Now what I need to think is, guys, of course you guess it right, what my options are. So, oh my gosh. So with each button, I have all right, we're gonna handle this. So the question asks, like, if you press these two numbers, how many, like, this is basically combination, like some sort of combination or something, right? Let me start my own timer too. Um so, like, when you press 2, there are three options. All right. A, B, C, all right? And you when you press 3, you have again three options. Like, this is good, man. This is good. D, E, F. Oh, so guys, so we need to draw the decision tree. But should I draw by number or by like letter wise or number wise? Um, Actually, the characters don't matter. What matters is that with each press, we get three options, right? We basically, with each press, we get, like, it doesn't matter, X, Y, I suppose, Z, right? And with each press, we get three options. So this is, let's say, button one. Like, when we press button one, guys, we have three options. When we press button two, we have, like, again another three option. Like a like a like, let's call ABC and ABC again and ABC again. Yes, yes. That now ABC again. For example, if we have like a 9, we have 3, we have, and the 1 2 3 1 2 3 1 2 3. Yeah, so we have 9. What does the question ask? At the output. So it literally, so it doesn't ask how many different combinations you can get. Like, literally, it doesn't ask the, like, a bring to fetch the combination itself. I mean, not the number, but it's themselves. So it really asks these stuff. All right, all right, all right. So this one is one answer. So we can save it. So, and this one is an answer too. So what we should do is, apparently, again, we're gonna use a temporary array, right? We're gonna use a temporary array, and the stop point will be, again, when we hit leaf node. All right, all right. Like, let's say we have like a length 3 or something. All right. If length 2, when it becomes 3, we stop recursing and we save the result. This is what I mean. So imagine having a function And if, let's say, like a let's say it is equal to length, we save the result. All right, save it into global. All right. All right, this is base case. And in our for loop, our options are, guys, our options. So like we need a dynamic for loop. I mean, not dynamic, but like kind of dynamic for loop. All right, because at level one, at level one, it's gonna produce. Oh my gosh, like all right, all right. So if we press button one, the for loop, we will should iterate among, or iterate through ABC. I mean, if it is two, let's say if it is two, ABC. If it is iterating DEF, I mean, if we press 3, our for loop should iterate through these characters. So imagine, like we need to imagine like special for loop. That special for loop should be, of course, for each for loop, but the iterable thing we have should dynamic. All right, let's say dynamic. So as we mm, let's say our function is called with button 2. All right, let's call our, like we are called with button 2, and we should understand and pre-orderly process it and translate that 2 into a, I mean, list of A, B, C. All right, yes, a list. And we should, like our for loop should iterate through that ABC. ABC, yes. So ABC. So ABC. Um. Uh. We in French. What is in Italian? C. C. Um. Like a, like our for loop will iterate through like these A B C C. Yes. So then, like it is E, like this is pre-order part, and it's ABC. Then like it will like this is also pre-order, like here is pre-order, and our function, like we should call our function. So I think, guys, we should iterate, I mean, not iterate, but move forward by one step, because our input is string. Yes, string. So we should go one forward. How do we go one forward in a string? I mean, one step right. Using a substring or something, or characteret. Yes, yes. Let's use an integer. All right. We should increment it. Yes, yes, yes. Let's use an integer of iterator. We can call it an iterator. All right. Let's make our function take an integer, and let's call it gladiator. Since we are talking now Italian, buongiorno, let's call it glad. I don't know how to glad gladiator. Let's call it glad. And glad, like we're gonna call our recursive call with 2 3, and glad is 0. By the way, where is 0? Like, is 0 here? Oh my gosh. Or here? Oh my gosh. Like, you will not be glad with this integer once the errors. Starts appearing. No, 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 no. Like Americano, can you tell me if zero is here or here? Could you please find it? It doesn't matter for now, but let's suppose it is here. I don't know, man. Anyway, let's start with zero. So all right, let's not waste any time. So let's start. Let's assume it starts from here, and as we iterate, like our function will, like we need a hash map or something. When the key is 2, we need to fetch ABC, and we need to iterate that ABC 0 equals k fidelity. But the leftmost or the rightmost? Where does it start? Where does it start at? Yeah, where does it start? Yes. You are saying leftmost, I think, right? Um so as we like we need to iterate through ABC, and when it is A, we should call glad with glad plus 1, indicating we moved forward by 1. And yes, we can still again share the same string, so it doesn't matter since our glad is now glad plus 1. uh, so in pre-order we need a structure for, like, how can we how like imagine a key value map. All right, key value map, and our key is, for example, 2, and our value should be a list. Yes, let's make it list of not stranger but string. All right, and this string will include ABC, and for example 3, that list is gonna hold ABC, DF, DF, DEF, ABC. Yes, I guess I'm right. So we need a structure for that. We need gladiator, our gladiator, and so we have basically solved it. We have, like, we basically now we are done. Yes, we are done. So I can type it. I can type this code, and now let's remove that part, guys. Let's start with creating a hash map. I don't know how to create it. Let's call it A. Oh my gosh, I need to start this. I need to maybe, I don't know, man. Hash map with string and um string and list of, not stranger but string, and new hash map. It's okay. No one really knows how to make it. Like, I keep forgetting it, man. Like, I need to memorize its method. So guys, we're gonna do it. We're gonna do it. So we have our hash map, and we need to create that hash map. Like, we need to put like a 2 comma, I don't know how to create a list, maybe using a new keyword, list of, oh my gosh, list of ABC, but let's call it AB. Oh my gosh, where am I supposed to, where am I supposed to AB? No, it should be standard. I mean, first element should be A, the second should be B. Maybe like this. I don't know, man. Oh my gosh. A, B, C. Is it correct? I don't think so, but let's continue. So we have, let's call it void. I mean, let's make it void, and our function func we have now we have like a period order part, and then we need to have a for loop or something, and inside it we're gonna have a function. And here we have, I mean, period order part again, and this is post order. And what we need to do is our function first of all should have something like 2 3, and our gladiator, right, gladiator, integer glad, integer glad, and our for loop should iterate through a b c d a b c. So we should get a b c. So basically we can create a for each loop, uh, for each loop. And how can we a no a dot get, what is our key? Our key is like a, we can have like a string, oh my gosh, let's call it string input. Our key is input dot character at glad is our iterator and gladiator at the same time. uh, Basically let's say our input is I mean 2 3, all right, 2 3, and our gladiator shows the current button. Let's say current button is 2 2. Now it gets the equivalent, I mean list of, I mean the equivalent of 2, which is abc, and we're gonna iterate through each character, and we're gonna add that character into our amazing, beautiful, spectacular, wonderful, shockingly good temporary array. But first we need to, I think, have a parameter of this temporary, what temporary, like, is it string, I don't know, let's call it temp. We need to add this character. Should we make it character, I don't know, but it doesn't get primitive, so it should have, I don't know, let's make it string. We can upcast maybe. We should add this character. You don't you don't need to make public study. Like, I don't want to focus and spend any time with details. I want to dump the core logic and then polish it. And yes, I need to do this too. But sadly, like, I need to first make sure that this is the correct way. Is this correct way of creating an iteratable americano? Could you please clarify? Because if it is, then we are gonna like populate this like this. But first, as I said, I wanna focus on the core logic as soon as possible so that I don't forget. So we have, why, I don't know. What do you mean? Like, this is correct, man? I mean, we need to populate this so that each number, like from 2 to 9, each character has its equivalent on the phone, and we should iterate through the equivalent. We need to check. We need to get from our list, that from our hash map, that list. We need to iterate through all the characters a b c, and we need to append, I mean, yes, append, right? Is it, was it append or add? I don't remember, doesn't matter. We should add the current character, and we should call using temp, and also we should increment by glad by 1, and we should pass the input again. Do we need to do something? Yes, if we are using temporary array, of course we need to remove, oh my gosh, like, why is this so our temporary dot size -1. So where is our decision tree? So we basically add a character. No, I mean, yes, add the equivalent of it. All right, and we remove it, and now we're gonna try another one, and we're gonna remove it again. Yes, yes, yes. So um, pre-order, we add the current character. We call. All right, we go one level deeper. All right, one level deeper. Now let's say we are here. All right, let's say these are A, B, C, and now these are D, E, F, D, E, F, D, E, F. All right, D, E, F, D, E, F, D, E, F. All right. Um. So now D, E, F. So we are now here. Like this is correct, man. This is correct. I think it's gonna work. Yes, this is it. So we have solved it. We have solved, guys. After 3 years, now I'm able to solve this question very nicely. So let's open this thing up. Where is code? What should we do? I think we should just, you know, all right. Let's copy the code. We have our func. I think yes, this is it, guys. This is it. So let's create our beautiful, amazing, wonderful, spectacular function over here. And we also should stop this. I mean, currently it goes on and on. What is our stopping point? Our stopping point is that if our gladiator, um, if our glad is equal, equal to the input length, then we should stop recursing. So we should populate these 4, 5, 6, 7, 8, 9, and then 4, 5, 6, 7, 8. Now, since I don't know the oh my gosh. English alphabet, A, B, C. We would know it, D, E, D, F, G, H, I, G, H, I. Oh my gosh. J, K, L, J. Oh my gosh. Why am I doing that, man? I can just copy this one and then ask AI so that I don't make myself, look bad on the internet. Uh, Populate this and give me back. Of course, I know the alphabet, guys. I just don't want to spend much time on this. Let's make AI to populate this and give the part we need. Actually, guys, like, let's look at the description again. No, we have 3. All right. Each number should have only 3 characters like this. Why did it change and make it like that? JKL MNO. So what is the 4th character here at 7? Oh yeah, we have. No, we have. We have 4 letters. Would it cause a list of? I should have used list of, by the way, guys. Um, so list. Instead of list, I think list of. Like, would it matter if we have like 4 letters? Would it work? I guess yes, because we are iterating. Maybe it is so flexible. Something is two verbs, I think. Make it, I don't know. Make it what? No, this will work. Like in the question definition, it also says um like the number, like a digit range is from 2 to 9. So we don't have 0 and 1. Where is the code, guys? After 3 years, we're gonna solve this. Make it a string array, and just make the program count it. So 0 becomes empty, 1 becomes empty, but 2, like using hashmap is just fine, I think. Americano. This is why. Oh, by the way, on the left side, it is not hashmap. We should use the interface name. Implementation side is on the right. Sorry about that. So like we have this, we have that. I think we can copy this part here and paste it over there. And inside the very function, we can call. And also we need a global store value, guys. Uh, so, but what is the, I mean, description? The return value should be, oh, so we should return array of string, array of string, array of string. Our temporary array is list of string. We add, let's call it AD. In our temporary, we have add E, and also here we should have global. I mean, in class level, should we? Oh my gosh, should we create? Maybe we should like create something like that. Answer a new array list, I think. Like, all right, and now we should save the temporary here. We should save the temporary over here, right? Like, I'm thinking that, like, if the base case is correct or not, I hope it is correct. uh so now, oh my, all right, so now we should call our function with these parameters. And oh my gosh, we should also create temporary array somewhere appropriate, which is inside the function itself. List. Oh my gosh, I'm writing quite ugly code over here. Let's call it temp new, and this is the implementation of that interface. Come on. We have temp. All right, let's share the temp, and then glad should be 0. I mean, should start from 0, and the input is the digits. make it digits and remove the type. And since we are calling the function, we don't need curly braces apparently, and we should return answer, but we should turn it into how to convert list of string to array of string in Java. Collection. We have studied collections, Americano. Oh my gosh. Recommended. Oh, this is ugly. So list of Apple. So list to array. This is our answer, I think. We can copy this part and we should paste it. Our list is what? Answer to array. Yes, I think this is gonna work, right? This is our answer. Sonra possibly 30 minutes. 30 minutes. Alright. Like we're gonna solve it. So this is it, guys. So we have our hash map, and we are calling our method. We are saving into our global value, and in our function, let's make it even bigger. In our function, like maybe this part might be wrong, but let's see, guys. Let's see. So if GLAD is not input length, but input length +1 it should be, right? Yes. No or yes. I think, oh my gosh. So imagine we add one and we call it yes, and in that stack frame GLAD is one more. Yes. Now we should add yes. But no, I mean this part is kind of hard for me, you know. Like I'm thinking right now is like, imagine we have our leaf nodes, all right? Like should we like this stack frame is created or not? If it is, what do we have as a temporary? All right, now like if it is created, what do we hold in our temporary? The thing we are holding in temporary, is it answer? Like imagine we have 2 and 3, and imagine we are in the loop for the 3, and we, let's say, add a D, we add D, and we make a call. Yes, so we made 2, not 2, 3 actually. Like, and also there is this first, like we are calling this with GLAD 0 and empty temp, all right? And then in its for loop we make these 3 calls, all right? And like in their stack frames they have like a, let's go yes, ABC basically. So they have like in their stack frame GLAD is 1 and temp, yes, temp literally, because since it is pre-order, since we added before the calling, I mean here temp is holding, let's say A, all right? Let's say A. And here in this level, in their stack frames, GLAD is apparently 2. I mean, GLAD is 2, and we have like in our temporary array, we have, let's call A and D, all right? In one of the nodes, we have this one, and we are now, I mean, we made that call. So like, so this is the call that we made. So now there is another stack frame. And in that stack frame, here actually, here, glad, glad is 3. What is temp? What value temp is holding at this leaf node? Because to be able to call this stack frame inside this one, in for loop, we should be able to make a call, but we can't right now. So most probably we don't even. Like, this is the part I kinda get it, kinda don't get it. Let's say we add like a and D, all right, and we make a call, and in that call, glad is 2, right? Yes, let's suppose glad is 2. Glad is 2, and um, actually, guys, yes, maybe it should be not 1, but length is all right. Length is all right. All right. If it is 2, yes, we add and we call, and so that length is 2, which is amazing. Then we should add it as an answer, because we are doing this as pure orderly. So in the next stack frame, we have the temp array as an answer, and the length is already 2. Then we so basically, guys, we don't make like these leaf nodes um, aren't getting created at all right. So length is 2 here, like at this level, length is 2, and this is all. This is what we all have, this is all what we have, or whatever. Anyway, so I think now we can just click on it and see the compile error, but we can fix it because of this little thing. And now we're gonna see the, of course, not correct result. Variable gladiator. So basically, guys, we don't have glad, so we should give 0. We don't have. Oh my, let's give it 0 and run it and get the correct result. Of course not. Incompatible. Yeah, now this, like this generic thing, or confirms to. I think we cannot convert. All right, we are not able to convert like a array list. Like this one to. Actually, we are already, like, our answer is already this, so we don't need to do anything at all. I think if we are adding correct thing over here, I suppose. Oh my gosh. Now another error, at least another error. So having another error is good, guys. All right. Incompatible types. List of string cannot be converted to. Line 25. How should we? I mean, this is list of string, and our return type is list of string. But we add list of string to list of string. I think this is what we are doing wrongly. Our temporary, we should turn this into String. Yes, we should turn this into string. And I think we can use this part. You can pass how to convert list of string to no. How to how to how to convert, I don't know. Uh I mean this one into string actually. String join. We have studied this, America. You remember? So string join. Oh, so all right. So instead of temporary, we give this one, and we are good to go. And the result is compile error because of this semicolon we have over here. All right, don't worry, guys. And the result is now, guys, everything is green. Cannot find the symbol. Compiler does, yeah. The compile errors doesn't count because silly mistakes. Like, so it character. What is A here? Uh, I mean, it should be this A. But it is inside letter combinations function. So maybe, guys, we can copy this part and remove it to the class level so that RB double A now has reference to correct hash map and everything is not green. Mm, identifier expected. I think it is because I don't know how to create hash map. I mean, it is string. The key is string, and this is list of string, so everything should be fine. What am I missing? Let's call it map. Like, it is not, of course, about only this thing, but why? I mean, like, oh my gosh, I don't want to manually do this, but um actually let's leave it A. All right, let's, for the sake of time, let's leave it as A. But the thing is, it doesn't allow me to use put method. Oh my gosh, how to add an element into hash map in Java? Oh my gosh, come on, man, it is put, man. Yes, it also uses string and then value string, and this is hash map by the. That's interesting. Like, can I create? We need, so we need to use string builder. No hash map. We need key value structure. But can I create a hash map using map? I mean, on the left side, I thought we have interface, and on the right side of we have implementation while creating a hash map. Let's see, guys, let's see. Oh my gosh, so is it the answer? Left side interface, yes. Right side implementation, so yes. So let's make it hash map. Is it correct? Like, it shouldn't be correct. Yes, it is not correct. So illegal start of type. What do you want from me? Come on, man. We have. Oh my gosh. Let's make it map. I don't know. Like, map should be fine. Like, we are literally insert. I mean, the first key is string, it wants you to see. All right. Like, like, like this shouldn't. Like everything just seems fine, but you know, this is a silly error we are getting right now, guys. Is it because we didn't import that? Let's see. Let's see. Yes, yes, yes. Oh my gosh. Let's run it. And everything is green. Oh my gosh. Identified expected. What kind of error is that? Come on, man. What is this? Like, this is quite. Come on, man. To fix it, move the statement inside the method. What do you mean, man? Like, it says that, like, can't I just instantiate hash map inside the class? Or should I make it like a static or something, man? If I should, no. That is strange, guys. Like I've seen kind of similar issue before, to be honest. Something similar to what is in Stream Arena. Like, what is Stream Arena? Ah, you are saying. Yeah, we can do that too. Yeah, yeah, we can do this too. Yes, yes. Like first, yes, yes. Now I get it. Of course we can. So first element like a one and starting from, yes, yes, we can of course use it. Yes, yes. Definitely, definitely. But I thought, hash map would be, good. This error happens because you place executable code. Yes, like we've hit this error before. I don't know the reason, but in class it doesn't allow us to, run this kind of thing. So let's. But why this one but not this one? I think this is executable. So if this part is executable, then what is this part? We don't execute it at all? What do you mean by that? We're going to ask this later, but let's, for the sake of time, let's copy this part into this part. And for us to be able to use that hash map, of course, you wanted this. So let's get that hash map, all right? I think this is the way. Yes? No. Let's make it map, and type should be the same because Java is strictly type, and paste over here, and now everything is gonna be green. But thank you for that. But now the thing I wonder is that um the thing I wonder is that, like, in the very same class I had this array list instantiation, and but this didn't give us a problem. But why on earth creating a hash map and also fitting it gives this error? So does this mean that initializing is not count does not count as executing, but adding some method is kind of execute or execution block or something? What do you say? So now, guys, we have another error, but we're gonna fix it soon. Hi, all right, guys. So we didn't give the reference of hash map. Now everything is gonna be green, and we're gonna be happy. Incompatible type string cannot be converted to character. So this is something. This is a good error, because what this hash map gives us is that not a character but string, right? Each element of this thing is string. So if we make it string, it will be amazing, and it's gonna give us some not green color, obviously. Method function in class solution cannot be applied. Required string. So all right, so now here as well we need to give a. All right, so it is a compiler, so it doesn't count. It doesn't count, guys. And now null pointer exception. Java util list iterate because the return value object is null. Why? Cannot invoke. Is this part? What is our input? I mean, input our input is digits, and digits here is string. It shouldn't be empty. Character add. So what does this return? What does this method return? Anyway, at this iterator, let's copy the code and now another question. Create this Java file, and I wanna debug this. So like this shouldn't get us null pointer exception because our input is same. It contains a character. I mean characters or character. Let's say 2 3. Like we have value at a hash map. All right, we have a value in it. So for example, if it is 2, we are returning abc base list of abc, and we're gonna like we are iterating abc. Like after fixing this error, we should be able to so basically we are in the back folder, and let's run this. So the output is not what I am expecting, is not what I expect. All right, here at least we don't have the null exception, but the thing is that, guys, we add 2 of them. Yes, now answer has, yes, so we literally add this, but what is this comma thing? AD, AE, AF. Yes, actually, like this is correct. What is the output type? We literally print them individually, but like a 3 here, 9. Do we have 18 characters over here? I suppose yes. But the thing is, we are actually, the count is 9 too. Final result. So what is the letter combination? All right. All right. So when, yes. So I think it is because of this. I mean, if we shouldn't have, like, we shouldn't add this one. Let's run it again. Yes. So now result is correct, I think. So what is the issue? Like, because count is correct, we are getting the correct result. Um, but I suppose AI fixed. I mean, let's ask this. One minor note. Hmm. Let's see the code. Do we need to do? No. Oh yeah. Alright, alright. We need to remove this part. I mean, I literally copy the string part from here. I mean, somewhere here. Yes, we shouldn't add this part. Alright. Now run this and like again we are having null pointer. Like how on earth? Why are you laughing? Why are you laughing? So like at least here like we literally see, but let's see. AI I think fixed something. Mm, can you please like make the code exactly I pasted to you so that I can debug and see it by myself, bro? Come on. It has fixed some part um, so that it gets compiled. Um, what is this part? So this is so about printing. You got it. Here's your code verbatim. Yes, yes, yes. Please, man, please. Nothing in your logic touched. Give it to me. Give it to me. So we have all right. Now I'm gonna like run it again and all right. Got. AI had enough and just fixed it. So yeah. Now we are getting this error at Java. I mean this line. Yes, the very same line. What do we have here? Unlikely argument type character for get object. Returns character value at specified character value. So it is character. That's why I use. So maybe we can just actually, guys, we should get the list, not the character. So actually, no. We are getting the character, but the thing we are getting from not HTTP, but hash map is list of characters. But the wrong part is here, guys. What is input? Input is string, so we can use character, right? I guess, guys, the issue is that we just need to upcast. All right, that's all. That's all. Let's save it, guys, and run it and see green. Hungry hippo. Input welcoming. Input character at returns character. A dot get requires a string. Yes, string. And now I tried uh, upcasting, but it gave com- completion error. What? Compilation error. Incompatible types. Character cannot be converted. So we cannot upcast. So how should we do that exactly? Like I need a string as a key here to get the value part from hash map. You are right. Hunger hippo. Um, but this is the only method I know that I can use on string. Maybe like string value of, right? Yes. String dot value of. You cannot escape from me, man. You cannot escape. Oh my gosh. One more. Yes. Save it. Run it. Yes, guys. Finally, we've done it. Input subset. Yeah. Input. What was input again? Input string. Yeah. We most probably we can use it. I use string value of. Both work. Yeah. Let's make it your way. Like instead of string static, um, we can use instance method. For instance method, you are saying that substring. For substring, we need start point and end. Uh, so if we give start point at this one and then exclusive end as +1, what would happen? I think we can get the same thing. No, out of bounds. How am I supposed? How am I supposed to use substring? Like I mean, I thought that I could give the start index as it is and then end index as start +1, but start +1 gives out of bounds exception. Um, while you type that, maybe I can fix the other error. Which error? Other error we have. Yes, this error. So how am I supposed to get? Oh my gosh, where are we? Oh my gosh. Like, how am I supposed to convert character to string? Um, let's, for the sake of time, I would just use string value of if it was already. Yeah, yeah, yeah. String value of is a good method that comes handy. All right. Just I wondered how to use like a substring method on these case. Yeah. So I think, guys, I can just copy this part and open here and paste it over here too. And we also fixed it. Yeah, all right. Now we run it and everything is, yes, yes, start index and end index. But when I give it, it gave me index out of bound exception. Yes, guys, everything is green. Now press this submit. And after 3 years, guys, after 3 years of not understanding anything at all about recursion, backtracking, and graph, and tree, and dynamic programming, now the time, like now I started understanding and internalizing, these topics, and I'm quite happy, and I'm glad you are here too, guys. Yes, we've done it. We've done it. Now the world is saved. Funziona spettacolo. Exactly. Exactly as you say, Americana. Buongiorno, mate. Funziona. Next up, lead Cotard. Like, I don't see any. Don't make me talk too much, alright? Like, let's see. The hardest question. Let's ask AI. Give me the hardest, but mm, I can ask. We were using this one, right? I guess this one. Um, what I mean is that this one. Um, let's open that one. Give me the hardest back tracking problem on lead code that I can use peer order. And anyway, let's give the hardest back problem on lead code. Come on. So we can do it, man. We can do it. I don't like, there is no heart in my dictionary, all right? I don't describe. I don't have the definition of heart anymore, all right? Let's see. I'm joking. The single hardest classic backtracking uh Sudoku solver is easy, man. Like, guys, the thing about leet code is it is always lying, all right? It is always lying. Let me show you an example. Invert binary tree leet code. You're gonna, what you are gonna see here as a definition, like the level is easy, guys. But it is not easy at all. And I learned that the way LeetCode calculates this level is just matter of the lines. How many lines is the code, all right? So this doesn't represent the level of hardness. This question is quite hard, even the maybe hardest question, all right? If you don't know, if you didn't internalize the recursion, there is no way for you to solve this question. Maybe it depends on the language. No. It doesn't depend on the language. So it, like, at least AI told me that most probably it's correct because it makes online search. So like LeetCode says, if you can solve it like in three, like let me open the solution of it, three in Java, because Sudoku solver is kind of easy too. All right, like look at the solution. Where is the solution, man? Look at the solution. Like literally, let's discard the base case. All right, like, literally 4 lines of code, and that's why LeetCode says it is easy, but it is not, guys. I can make sure you. All right. I would imagine inverting binary in Rust would be much harder than how. Actually, guys, like since it is recursion, like let me open uh in Rust. I don't suppose, like, if the language you are using is not assembly, in every language I don't see because this is recursion, uh like we are gonna see again 4 lines of code. Trust me, bro. Yes, this is it, guys. Like, the hard part with recursion is not about the lines of code, all right? This is about the logic part. Look at it. Of course, like since I don't know Rust at all, this little thing like kind of looks ugly, but uh and my friend like here it's work okay. uh it just works okay. Also, like we had a stream where we talk about Rust, like this, like again we see 4 lines of code, nothing more than that. If the language you are using, as I said, if the language you are using is not assembly, then oh, it was reverse linked list. Let's open it. Reverse linked list is also in recursive solution of it is uh, kind of easy. Let's open it. Reverse. Let's see. I don't suppose we're gonna see, like, I think we're gonna see, let's say, like a, I don't know, 3 lines, 4 lines of code again. Yeah, we have again 4 lines of code. Like we like 1, 2, 3, and 4. Like it doesn't change. But Rust is in my in my list too. I wanna learn this language very much, but after Python, I think. And also, guys, I will stream on Monday for 17 hours, and we're gonna study LeetCode and Python, and maybe Java. I don't know, but I will be glad if you visit and come my stream on Sunday. So this is about recursion, guys. This is about recursion, and this is hard. All right, this is hard. This is not easy at all. Maybe it was pre-AI and nobody knew how to. Yeah. It can be. It can be. Like yes, I agree with you that. I agree on with you that because I agree on that with you. Anyway, because now AI makes searching quite fast, and you can find almost anything faster than ever. So yeah, but again, AI like didn't make your learning process some magical, and if doesn't make you understand the concepts easier. What it helps is that it brings you the sources that you can read, you can study faster than ever. But that's all, because you are the one who needs to find how you learn, basically. All right, AI can speed up the process, but again, you need your neural connections, all right? And on YouTube, like they teach you like let's let's open, all right? But I don't want to talk about any people bad about them. But most of the people on YouTube explain this recursion iteratively, all right? They make this mistake. They literally show you the each stack frame, all right? Like let's say we have a tree, all right? They literally go DFS like a CPU, all right? Like CPU does. They go this way, they go level, and then go up, try another one, and then another one, and come back here. Like there is no point of doing that, all right? We are not a CPU, all right? You don't learn by this. This is not about recursion. And if you don't internalize recursion, there is no way you understand theories. There is no way you understand backtracking. There is no way you understand DP. There is no way you understand graph. You can assume that you understood these topics, but as soon as you see a problem that you haven't solved before, you're gonna fail. You're gonna fail, and you're gonna think that, am I stupid? Why can I do it? Like, is everything smarter than me? But it is not about that. It is about the approach. You really do have a vendetta against these because I've struggled with these for a long time. Like as I said, the question we just solved, I tried solving it like a 3 years ago, 3 years ago, and I didn't understand anything, and I thought, like, am I stupid? Like maybe the coding is not for me, and I'm not suitable for it. But it's not about that. I read a book about recursion, and in one page it explained, the professor of that author of that book explained that most of the students explain, approach this recursion concept wrongly, trying to keep every stack frame in their minds, all right, because to be able to solve this, if you want to really do in CPU way, you really need to keep every node and every value of every argument here in each stack frame in your mind, all right? And then as the last node returns, then you have the answer. And then you have, but like, let's assume you have like a four levels of tree. I mean, you have a tree with four levels. There is no way you keep all the arguments in your mind. It is not the correct way. I cannot do lit code, brain to smooth. Uh, no, no. Like, it requires some dedication and for like a long time, long time, long time. That's why it's hard. Like, uh, you need to study for a long time. And if you are in college, in uni, and if you started studying this topics, this is great. All right, you are far away for most of the people. Because I studied lead code on my third year in uni, but I failed understanding this recursion for almost 2+ years. And I just read like this book 6 months ago or something. And after reading that line, that page, everything changed. All right, I even plan to create a post on my LinkedIn, but I constantly postpone it. But soon I will create a post there, and I will share this experience. Amico, we might need to forsake summer and just study. um so yeah, so we have solid, guys. So next question, guys. Letter community, amazing. Like, this question is asked in Amazon, Meta, Google. Now we are ready to enter to Google, right? Let's go. Let's go. Generate parentheses. Uh, Actually, I can, you know, paste the code from. Maybe we can just open the code. All right. Uh, like, this is easy part, and maybe we can copy that part and paste it over here. And then the next question, generate parentheses. Let's open this up, guys. It's gonna be so fun, guys. This is gonna be the third time we saved the world and everyone loves us. Like, I think I have solved this problem before. Um, yeah, but let's solve it again. I think this question can be solved using stack, I think, but we're gonna try solving it using pure recursion and peer order and stuff. I have generated parentheses. Yeah, but it asks three. I mean, you only used one, but we need three. Um yes, three opening parentheses. Oh, it really only do be like this. So let's try drawing the decision tree of these so-called well-formed parentheses. And by well-formed, um, it means that I don't know what it means. Let's read the question. Does it say anything? No. Like, we need to create a formula for this one. Let's actually, if this is the output for n, like a real full output, we can just pick a different color first of all, and then try drawing. All right. So let's look at this first three opening parentheses. This is one output. So I assume, guys, as I assume, this is opening. All right. By the way, what are our options? Our options are, guys, two, opening or closing. So I don't have to draw like a three choices as if we have three choices, but we have two, opening and closing. So to generate these, let's say, combination or something, right? We need three one right away. 3 1. So one, this is one. I mean, this is two, right? And this is the third one. Opening, opening, opening. But the thing is, where are we supposed to put the closing ones? I mean, because the length of the output is not 3, guys. It is 6. So does it mean that we need to, oh my gosh, we need to, like this is first level, oh my, this is first level, this is the second level, this is third, and then, but after this level I cannot use opening. I mean, guys, this is literally stack question. Or like, if we use stack, we would be able to solve this easily. We would use stack, and for the each opening parent, I mean, oh, like, you can store opening ones, and as you put closing, you would remove this one. All right. And at the end, if you have nothing left, then you can count yourself as successful. Like, I know there is a solution of this problem using stack, but now I want to solve it using backtracking or something. But the translation, oh, so two choices. The three is how many stack frames to take. Like, now I'm trying to figure this out, Americano, because the, oh, actually, guys, like, length of each string is 6, but length of the output is 5, right? Is 5. But what I'm trying to figure out is that when exactly and where exactly we're gonna have this, and how many levels we should have. Is it 3? If it is 3, let's assume it is 3, guys. If it is 3, and each level, if our choices are, opening and closing, let's say I pick this one, and in this level, let's say pick I this one, I mean pick this, and at third level I pick this one. So what we have now here is this one. All right, let's assume, guys, we pick this opening one and then closing one. All right, uh and then closing one again, but it isn't valid, by the way. So we need to have a mechanism to recognize valid ones, distinguish valid ones, and bad ones too. Like after opening one, you can select one closing, but if you make this very choice, this is very bad choice. So maybe we need a counter, guys. Counter for openings and counter for closings. All right. The difference, I mean, they can be they can be equal, but closing cannot be bigger than opening. Now we are getting closer, guys. I really like this idea, but the thing I'm trying to figure out is that, like, how many levels uh, are gonna be there in our decision tree, because to be able to draw a decision tree properly, one should know how many choices does he or she have. All right, like apparently here we have two options. Let's assume that. All right, but like if like in each level we can we pick only one, obviously, but at the third level, by the end of third level, we're gonna have like stuff like this. All right, but the question says that like I see 6 parentheses here. 3 of them is opening, 3 of them is, or are, I don't know, closing. How levels equals n plus 1 fidati. Levels n plus 1. What is n? If it is n is 3, then you are saying that level should be 4. Welcome, 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 Hans Sohai. I think there's an evidence where learning interview style assessment like LeetCode comes easier after doing it for the first time. Let me read it again. Welcome in, by the way. I think there's an evidence where learning interview style assessment like LeetCode, yes, this is what it is, comes easier after doing it. Yes, yes, it totally about practicing, and also it's totally about internalizing. All right, because after some point I started saying that, like, I now don't need to see any different question, but um, like even if in the interview I see a question that I haven't seen before, if I manage to uh, analyze the which topic it is and which methods I can apply, then it is just matter of um, time or effort. Because when you see a problem, the most important thing is which method you're gonna apply. Are you gonna apply two pointers? Are you gonna apply binary search? Are you gonna apply, let's say, post order traversal? Are you gonna apply DFS, depth first search, or BFS? Should you apply stack? Like, can you solve it using DP? Is it DP question or greedy question? Like if you can understand this, then it becomes easy. Like assuming that you studied all of these topics. Yes. So now I internalize pre-order and post-order traversal very much, and I am quite kind of familiar with drawing decision trees. But now, now I need to find a way to decompose. I mean, decomposite this basically. Like, if I manage to draw the decision tree, then I will start coding. But uh, I'm trying to find a way where to put these closing choices. All right, because if if we have only two options at each level, by the end of the level 3 we have only length of 3. But in the question it says length of 6, like each of the results containing like a six parentheses. Where do we get that? Like, where do we actually, guys? Yeah, where did we get that? Them. I mean, for example, to like to be able to create this combination, I should give decision of opening and then decision of closing and then opening again. Like each of these are is separate individual decision that we need to make. These are like each position, like opening, closing, opening, closing. So each of them is a standalone decision. But our our decision tree only shows part of it. Or, guys, or if we increase the level, all right, if we make our level not 3 but not 4, not 5, but 6, but then this is gonna be huge. By the end of it we're gonna have like 64, right? 64 is not huge. Maybe this is the way, right? This is the way, guys. Maybe. But imagine, guys, imagine n is not 3 but let's say 10. All right, what is the constraint, guys? Constraints. Oh, guys, did you realize that like this is the answer to our questions? All right, like the constraint doesn't go, let's say, 10, 20, because, guys, if it was, let's say we have n equal to 10, double it 20, then 2 to the 20 is something huge that our backtracking approach cannot solve. All right, but since the constraint is very constrained, it suggests us, it is really telling us that don't worry, man, don't worry, we just love you, you are great, you're gonna handle this, you're gonna learn. All right, we trust you, you can use backtracking. It is like the owner of LeetCode website is literally telling us, telling this. All right, so what we need to do now is, guys, if n is 3, double it and give it to the next person. If n is 3, double it 6, and we need 6 levels, guys. This is correct. This is correct. We just we shouldn't hesitate. In each level, our options are opening and closing, and then again, now we need to think about is that validating these options. All right, because after, and to validate, as I said, we need, let's say, opening pointer, opening opening p, opening p, and closing. All right, all right, so opening, closing, and then again, and then again. All right, uh, opening, closing, opening, closing, opening, double. All right, so we're gonna have 6 levels. We don't need to draw every line, every level, but the idea is, guys, imagine we have a recursive function. All right, and now we need to think pre-orderly and post-orderly. By pre-order, I mean, what should parent give his child? All right, for example, imagine this is you, guys, this is you. Now we are parent for this. What should we give? We should give the amount of opening, let's say op and closing cp. We need to pass these parameters. Here, as a like from perspective of this node, we have only one opening parenthesis and zero closing parenthesis. Carry down we need to carry down this information. All right, this is pre-order. Post-order part is that what will happen when our, like, let's say we are this, all right, we are parent, all right. For post-order traversal, post-order approach, we should think about what this child will return to me and how am I supposed to process it, or do I need to do anything actually. Let's say let's say like what is left child is gonna return to its parent. I think it is the answer. mm, Generate all combinations, like what left, I mean, what is the left child gonna return? I think all the possible combinations, like a very validated parenthesis combinations, I think. And right child is also gonna return all the valid combinations. And as a root, guys, as a parent, what we need to do is just sum these up. Sum these up. Arigato. Arigato, guys. So now let's design our function, guys. These are beautiful, amazing, wonderful, spectacular, um, tranquil, and also serene function. And the like this is recursive. This part is pre-order. This part is responsible for pre-order stuff, and this after the function. This is for post-order. For so when we are thinking about which values that parent should pass into his children, we said that we have opening parentheses and closing parentheses. So, and also we said that at each level we have two options. We have two options. One, guys, is, you guess it right, opening, and the other is closing. So we need to find a way to represent opening choice and closing choice. It is easy, guys. It is easy. We just, add append and then call it. So let's copy this part because it looks very nice. Paste it over here. And guys, the meaning of this opening over here is just in the pre-order part. We're gonna, like, we should have something, some sort of list or something, and append it. Oh my gosh, my neck. Append it. Um, I mean, like, we should append opening. No, we like, actually the question ask really asking this one. So we should generate these combinations. We should, like, so this means that we should have a parameter, like a list. But again, we shouldn't share the reference of that list, but the content. So maybe we should create, uh, I don't know. Anyway, we can focus on this later. Let's call it list. We are appending opening one. All right. And for calling the opening choice selection, we should increase opening plus plus, since we appended opening parentheses, and closing parentheses is same, and share the list again. And after that, guys, after that, like after calculating this one, most probably, you guessed it right, since we're gonna use the same list for the closing part 2, guys, you guessed it, very nice, very nice. Remove. We should remove it, right? And for closing, um, we can we can you know we can append, no, remove, and then so we need to append again, guys. List now appending with closing one, guys. All right. Now opening parentheses stays same, but closing parentheses plus plus, and I share the reference of that list, and we are good to go, I think, right? The thing is that, guys, we also have, like, since we have, let's say, six level of tree. This is huge, all right, this is huge, and it takes too much time. So we need some sort of optimization. Instead of trying every possible combination, but periodically, we can check if, I mean here, if if the closing parentheses, the number of closing parentheses is bigger than opening parentheses, then this is bad. This is so bad, and we need to. We can immediately return. We like this is called, guys. This is called pruning. I assume, all right. Most probably, it is really called pruning. Like what it means is that instead of discovering, instead of exploring, guys, exploring every option, periodically, which is here, guys. Here is called periodically. I mean, while going down, because you can go up to, this is called post, and while going down, guys, this is periorder, and by periodically, meaning before calling the recursive function, guys, we have a condition over here, and if it doesn't suffice a rule, we early return, all right, so that we don't even call this function, so that imagine it has lots of nodes inside it, because this is basically a subtree, and by using this pruning version approach, we don't need to explore nodes over here anymore, all right. This saves us some time, basically, and this is period order, all right. This is period order. um yeah, so I suppose this part is also correct, like we are appending, and then we are sharing the like sharing the list, and also we need a base case, like we need a stop point. We are like we write stop point, uh, stopping point in a like period order wise. So here, when are we gonna stop? We're gonna stop recursing um, when the um, when the total number of when the um, when the total number of parentheses used is 6, which double of n, we can stop, right? Or at 7, I don't know. So now let's open our code. Oh my gosh, this is so empty, guys, so empty, like my stomach right now, because I'm hungry. But it is all right, guys, it is all right, it is all right. What we need to do is pray. Pray and hope for the best, all right. This is what we need to do always. As we said, let's start with creating a function called func, which is the way I call my recursive functions, and I really like calling them func. our two options are appending like a opening, I mean opening, not opening, opening and closing, so we are calling like this one, and then this, like we need to call this one too, um like uh so what they are returning, what are they returning, so and what should we do with the return type? As a root, we should we, as a root, guys, as a root, guys, I don't know, like our functions basically, adding parentheses, and they when they hit to, base case, we basically maybe they don't need to return anything, all right? Let's forget about the post order stuff, but instead let's focus on only pre-order, because we can just create a global value here, all right? And our recursive functions can store their answers there, all right? So um so now we have two options. So we need to have temporary, I suppose, string, all right, so that here we can add or append, I don't know, it depends on the language you are using. Let's call it add, and I remember from the last question it is add. Let's add, guys, a opening one, all right? We add opening one, all right, and we basically call recursively, so that we go one level down, and when we go one level up again and come back here, we should remove, obviously. You are so familiar with this approach, right? We've solved tons of questions in backtracking today, so now you are so familiar with that. I mean, we should remove, you guess it right, last element, the last element, all right? So we go one level down, we created, and we explored every possible action, possible combination, and then we come back, and then now it is time for us to discover the other option we need to explore or complete, which is closing, and then we make our explore, and then you guess it right. uh, I yes, so yeah, so we do this for some other nodes, we need to remove, I mean, we do this remove to like this part, right? So imagine we have a tree, all right? Imagine we are here, all right? Imagine we are here as a right child. If we don't remove the parentheses we added, we can return, and this can return to here the temporary holds, open the closing parentheses inside it, all right? And when it makes another, closing here, it should have here single closing one, but since we didn't remove this one, now we have double closing parentheses. So the reason why we do this remove is exactly this, all right? We basically remove upon returning, so that the next you know right call uh, can have the correct combination, clean state. It can continue from clean state. Remove the last element, which is awesome. So now the thing is that, guys, we need some like a optimizations, because otherwise we would end up with, trying like a, I mean, everything, like imagine we have like a huge tree, all right? This can take take some time because we double the input size. Let's say input is 4, we double it, it is 8. Now we need to create a tree with 8 level. Oh my gosh. And 8 is, guys, as you guessed it right, 2 to the 8 is, guys, 64, 128, and then you guessed it right, it is this. So we need to create this number of nodes with the input size of 4. Imagine what would happen if the input size is 20, then 2 to the 20. Oh my gosh, this is unsolvable, you know. So that's why we need some sort of mechanism, like a validated mechanism, because the question asks that, like, some certain of order, all right, for each. I mean, the formulation I created, I hope it is correct, because um, like the number of closing cannot exceed the number of welcome Tarkus Karkus, um, combi combinatorics problem. I'll give it a shot. Kind of feel like doing some lit code today. All right. So we are what we are solving, like, we are mostly studying pre-order, and I learned that I'm quite familiar with post-order traversal, like expecting answer coming from your children, all right, let's say left child and right child, and they, when they return, I can imagine, like, I'm quite familiar with this approach, and let's say this return x and this returns y, and I can do whatever with them and return what I like, all right. I'm quite familiar with them. Now we are practicing a period order, where now we are child instead of parent. We are looking from, like, we are looking at world from eyes of child, and we think that what would what would be great if my parent give me. For example, in real world, everyone expects money, all right, inherit some money. So we are saying that it would be great if my parent give me some money, all right. Here, like, we are child and this is our parent, and we, like, via the argument we take, um, like, we get this information from our parent via parameter argument. But here in post order, we don't need argument because we need now return values. And here in this question, um, we don't actually use post order because, like, at least now, at least so far. But what we want is, um like a understand if, like, the rule, like, there is a rule, all right. The number of closing parentheses cannot exceed the number of opening ones. So we need to give this information, we need to carry down this information to our children, basically. That's why we need arguments instead of return values. Today's goal is just practicing pre-order very much, because I've seen lots of greedy problems, all right, and, like, they have, like, a running sum, like a running state, all right. Imagine even the cadence algorithm has the uh, same style, all right. While going in on, we we have some running sum, like a history, or a, like we can call it history, like a parent history, ancestors. We have some knowledge coming to us, and we do some our processor with the current index using the running sum, all right. So I find this kind of greedy problems quite resembling the pre-order approach in recursion. So that I thought that it would be great if I practice pre-order very much, so that it can even help me in greedy problems. Because in greedy problems, like, it is almost always tricky to find that, tricky part, because, uh, for example, jump game, there are some tricks, as I call it. But, I find this approach, so we are now studying, pre-order. And now the rule, I think, guys, is, as I said, like, a number of opening characters, parentheses, uh, cannot exceed. So we need to transfer this information by arguments, all right. I mean, arguments. So now we should design that argument part, because currently our function takes only like a temporary array. All right. Let's see. Let's say that, guys, we have what term we did we use for opening, like right, um opening parentheses. All right. So since we add like a one opening parenthesis, we should call this using this one. And then for closing parentheses, we shouldn't change. And here, since we don't add, we didn't add any value to opening parenthesis, we don't change it. But for closing parentheses, we should increase the number and comma. And then, guys, since we need to optimize this, all right, since we need to optimize, because otherwise we would end up with this exploring many things, we can add an if statement. And then we can say that if the number of uh, like a closing parenthesis, if their number is greater, I mean, how many greater, how much greater, uh actually it cannot be greater than opening, right? Because if it is, then we basically break the rule. So if it is, then we just return and stop recursion, stop exploring, basically. um and what is the, like, this is one rule. And what is the base case? Now we need to design the base case. I mean, we add opening one, we add closing, add opening, closing, opening, closing, opening, closing. Yes, yes, yes. But when is this exactly gonna end? Um, Actually, if the length of the temporary array, guys, if it is equal to double size of n, right? And this, let's imagine we are like today I struggled with understanding this part quite much. Like let's call one more time, and if the length is, you know not 2n but 2n plus, let's say, if the length of, the size of this temporary array is greater than 2 times n. What is n, you may ask? uh, we should add integer opening parentheses, integer closing parentheses, and then it in the beginning, let's add n to in the beginning, integer n. And then let me open my this font too. um so if it is bigger than 2n, so we should stop, and we should save the process, I mean save the not should we save the temporary array, or should we create another array with temporary? I actually, yes, I think new, today we done this before, like create array list. In, I think inside the parentheses we were adding the temp array, and we should add this new list to our we can create our global answer, which is again, I think, list of lists, uh, like a like a like what is the output is string, array of strings. Output is array of strings, array of strings, array of. So we can basically create list of, string, answer. Let's initialize it, new array. This is the implementation. Compiler error on line 13. Like, we're gonna get these compile errors, don't worry. Just don't, not yet, not yet, just wait. Just wait. couple of minutes, and then we're gonna start getting these errors, Americana. And my neck is hurting very bad. So we have array list. We need to initialize it. Um, yeah, all right. We can give this two, right? Why not? All right. And now here we can call our function here. Uh, do you mean? Oh, what is that? Americano. You started speaking like computer language alongside with Italian. I don't see any error here. I see a swan here. Um, can I edit? Yes. Wonderful. Let's open my neck. So now the first argument is n. Opening number of opening parentheses is 0. The closing ones is also 0. And then the temporary array. Let's create a temporary array, guys. I think like that one, and we can give the pass the reference of answer. Now we are just calling our recursive function, but if is our code right? So this is our like a pruning phase. This is our pruning phase, all right. um we optimize it basically. I meant on yours line 14, like, is this one? Like we are creating. Oh, all right, now I see. Now thank you. Array list. We need to create this array list and also put it into our answer. Thank you, Americano. Thank you very much. We appreciate it. We appreciate your companion and contribution. Oh my gosh. That was such a roundabout way. Brain has melted. um so if go like after solving this, we need to take a break, guys. We definitely need to take a break now, not now, but after solving this one. But today what we have achieved is that, guys, solving, oh, Carcus, was a fun little problem. Been a while since I did DFS with Catalan constraint. Oh, what is that Catalan constraint? Was a fun little problem. Let's see. um Language residency requirements. Let's call it lit code. Like before this question, we have solved these letter combinations of phone number question that I've seen 2 or 3 years ago, and I didn't understand at all. But now we have solved it, and luckily we could manage to solve it, and I'm quite happy about it. Now studying hard pays off. Started paying off. Um, yeah. Now I should just practice more, because back then this question seemed quite hard. Now it is not. I just think of what my options are, and what should I do with going each level down, and what should I do with in the same level with the siblings. Um, so it is amazing. So let's look at the key Catalan lit code problems. Interesting. Generates all combination of valid from. Oh yeah. So key Catalan lit code problems. So generate parentheses is, I think, one of the Catalan lit code problems. Wonderful. frequently appear in leet code problems, particularly when counting combinations, binary trees, or paths. All right. Recognizing the pattern allows you to bypass massive combinatorial calculations. Yes, yes, yes. Use efficient math or one-dimensional dynamic programming. That's what we are trying to go. So, all right. Um, so we have, all right, we have this pruning. We are This is our base case. When we hit the base case, we just save the what we have all found, and we add opening parentheses, and then create a new world. All right, with this by increased by one, and then we remove the last element. So because in each level we have two options to make. This is the first one, like adding opening, and this is the second one, closing. I think this is just fine, but it doesn't look full and complete. But let's hope for the best. And now we are getting an error. um this is abstract, cannot be instantiated, so I need to use array list over here, I think. And also I don't need to give this one, I suppose. Let's see. But I think I think I should. Cannot infer type argument array lists. Mm, let's see. That is interesting. That is interesting. Um, like, is it all right? We have these ones, all right. Like, because here we don't give the type on the right side, but are we supposed to give it? Oh my gosh. Incompatible types cannot infer type 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 arguments for array list. I think, as Americana said before, we have a compile time error at line 14, but I thought we have fixed it. All right, so does it say that we need to add this type here too? No. Why am I getting this error? What I'm trying to do is that, like, creating creating copy of that temporary array list, and save it in our. I think the type is not matched, right? Is not matching. So answer is list of string. So I should add string, but instead I'm trying to add list of strings. So maybe this is the problem. Maybe we should turn this temporary array into a string, right? So I guess we had this before. We had done this before. We should turn this one into, convert this into string in Java. String join. Yes, we have used this string join. Let's see. So here, instead of this one, I mean, what should we do? We should paste this one, like we should copy this one, paste it over here, and don't use anything. And this is the string we are looking for, right? I mean, we want. Let's remove. All right, this is the string we want. Seems all right. Let's try. Let's give it another shot. Method func in class solution cannot apply to given types. So I think we are missing a parameter. All right. Here we have three parameters, and our function 1, 2, 3, 4, 5. Which parameter? Yeah, so we need to pass n, and then we have temp already, and then we need to pass the answer here again, and then n, temporary, and answer. This should work. Let's try again. Missing return statements are functions. So now we should return obviously the answer. Let's run it, try it, see it, and and then fix it, guys. Oh my, wa mu shindeiru, guys. Boku nande ya shindeiru, guys. What are we gonna do? Expect, like, I think, guys, we are quite close, right? I mean, close, like we are almost there. We are almost there. We are, let's say, a few iterations away. We are a few iterations away to get, like, turn this into this. And don't worry about these little three dots. All right, this means we are closer, almost there. Then highlights the output. um guys, don't worry about it, guys. Yeah, don't worry. All right, so since I see the, so guys, the error is basic, guys. I just forgot. No, I didn't forget. Guys, don't worry about it. Like trust me, guys. Just trust me. Don't worry about it. Don't worry about it. But how on earth, you know, we got we got this many results? I mean, like, for case one, what is this, bro? I mean, it seems that, like, for example, yes, guys. No, like, it is closing one. Like, this shouldn't happen actually. Like, because we have, if the closing one is bigger, by the way, like, giving argument like this is okay for function recursive call, right? This indeed should not have. No. We're gonna fix it. Come on, easy, man, easy. Like, let's ask this AI. Can I use this in recursive functions? Like, I mean, this one. We're gonna handle this, guys. Don't worry about it. So in JavaScript we shouldn't do this. In C++ we shouldn't do this, but how about in Java, man? Come on. I think it is okay, but the problem, like, I mean, like, we are already checking, guys. Like, we are already pruning, all right? If the, closing number of closing parentheses is bigger, if they are, because, for example, guys, um, um, here, I mean, here, for example, the closing parentheses. Oh, guys, it is not about the number. I mean, it is not about the number of times, but the thing is, I thought that, for example, like, we add closing parentheses and then another closing, all right? In each addition, we go one level down, right? One level down. So imagine, guys, imagine we have this one empty. All right, we have this one empty, and then we like opening decision and then closing decision. All right, like we even shouldn't be able to call this. All right, but how this code can, as I said, we shouldn't even be able to call. Actually, guys, not. I mean, I do. Like this seems correct place for checking if the number of closing parentheses is bigger. Because if it is, so like let's say we call it, all right, and here in its pre-order, the closing parenthesis is 1 and opening is 0. So we don't even discover this right subtree, all right? We don't do anything with this subtree at all, guys. At this is my idea, but apparently it doesn't work like that, but it should. uh how about the second case? The n is 1, but here we made 3 choices instead of making 2. So we also have an issue, I mean, on our base case, like a maybe let's make it equal to, all right, let's make it equal to, like, I always hated these base cases. Let's open the case 2. At least now we are making 2 choices, which is good, which is amazing, wonderful, spectacular, tranquility. All right, tranquil. But let's say, but we can do this. Like this is wrong. Yes, like at least this is the bug of my code, because we are looking like opening one is bigger and we can still add another one. So my algorithm fails at this one, but my algorithm shouldn't fail at this one. All right, closing and closing, because it shouldn't pick closing at the first place, in the first place. But it is making this choice. Why? Why, man? I think, I mean, like we have, okay, we have this, like, I mean, like we have this condition over here. Let's trace it. Um, like we have func, all right, we have func, and like CP is 0, like a closing parenthesis and opening parenthesis is 0, and then we have two options. In these two options, like we first, let's say, increase the closing one and keeping the opening one same, and in the other one we increase, let's say, in first one we increase the opening one, right? So it doesn't matter, but let's put it in this way: opening one 1, I mean plus plus, and closing parentheses 0, minus, not minus, stays same, and opening one will stay same, and closing parentheses increase. All right, we make these two choices. All right, so opening and closing. So in this function's new stack frame, let's draw it here. Now it is, opening one is one and closing one is zero. um oh my gosh, opening one, closing one, wonderful. So now guys, now we are checking, right? Now we are like, this is what I'm talking about. Now we are checking if the closing one is bigger than opening one, and now it is. So maybe, yeah, so it is. No, not it is, like opening one is greater. But here, let's draw a stack frame. Opening one. Oh, I see, guys. I see. I think since like we are increasing here, but we don't we should also decrease it again, as we also should decrease the closing parentheses there, because we are using the same parameter. So now guys, so now guys, yeah, actually it is kind of better, right? No, it is not better. But here we have 1, 2, 3, 4. But previously we had, I mean, we have like a 1, 2, 4. We have 4, and when we don't have them, we had more, right? So we can think of it like we had some improvement. We've done some improvement. Let's open it. No, like it is. So, but at least, guys, but like we should we should do this, man, because here in this stack frame, when we increase this argument, opening parentheses, and when we give it here again, we basically, how come case 1 becomes infinity but case 2 stays the same? uh like, oh, I don't know. I don't know. So for case 1 we are getting a better result, right? So this is an improvement. All right, all right. um so we increase opening parentheses. All right, something are something are better left unquestioned. No, no, we're gonna handle this. We're gonna handle this. We're gonna be happy. We're gonna save the world. Everyone is gonna love us. So we have opening parentheses here. We increased. So let me, maybe guys, maybe guys, like I don't know, it is related to this, but let's increase it and then pass it. All right, because I don't trust this this recursive stuff. I should increase now the opening parentheses. No, I mean decrease the opening parentheses. I mean, what am I doing? Decrease the opening parentheses and then increase the closing parentheses by 1 and then decrease it by 1. I mean, not here, but after. We're gonna handle this, guys. We're gonna handle this. Just trust me. So basically, guys, we are adding these opening parentheses here. We are increasing the number of opening parentheses by 1. We are calling our function. Um, let's see. Uh, so we have, like, we need to add 1 over here, guys. And I think now it is kind of better, right? Oh my gosh, guys. Oh my gosh. I don't believe it. Like I have changed like a increasing and decreasing like a before, I mean like a using this one. Now we are getting better answer. Like apparently um, when we call this function with plus plus, it calls and then the increments. So while calling, we basically don't increment it. So opening parentheses stays same for this function call. That's why we need literally need to increase and save it into our stack and then call it. So now, like this is quite interesting, right? Now we are getting closer. Now, yes, guys, amazing, amazing, amazing. Now, guys, we hit the point where my algorithm design, where now we have a bug. The bug is that, guys, I told my like in our solution, guys, apart from this post order, pre-order stuff, I told that, I mean, the in the question, like the only logic is that closing parentheses cannot exceed opening parentheses, all right? And look at the results. Like opening parentheses don't exceed closing one. So this is basically right. So here now we can celebrate, we can be happy, we can assume we saved the world, but we can assume, all right? Um, so now our approach has a bug. We need to find a smart way of solving it because only checking the numbers is not give the 100% correct solution. So we need to find another smart way of doing that, basically, guys. I mean, um, we also, I mean, like I have a trick, guys. After like when we hit this size, I just like this is like this doesn't count. This is not a good approach, but I can count the number of closing and opening, and they since they should be same, we can eliminate some bad cases too. But still, for example, even this approach doesn't like won't solve this case. All right, imagine um, imagine you have opening parentheses. Actually, guys, if we combine like a this one, I mean the difference cannot exceed, and then the number of opening and closing should be same. If we combine these two, which we are doing here exactly, then guys, maybe we can find the solution, right? Like, is this real, guys? Are we gonna be able to find an answer, guys? Let's um, count the number of um, actually we don't have to Unix. We need to they should be same. So basically how can we do that? We can create basic for loop, I suppose, right? Let's create basic for loop, all right? Integer I starting from 0, and length like I should be smaller than the length of or size of this little thing, and we should increment it by 1, guys. And also, guys, let's count the number. Like I really wonder if this approach is gonna work or not. So integer openings, all right, let's start from 0, and if we find opening 1, guys, or maybe flag will be great. Carcus, do you need to count when you have opening parentheses and closing parentheses as arguments already? That's a brilliant question. I have. Hmm. Yes, I have. Yes, I have. So yes. Yes, I have actually. So we can, I mean, yeah, thank you. So we basically compare these two, and if they are same, then we are good to go. If they are same, then we can add this. Let's try adding this as an answer, because we already have like a prerequisite of this condition, which is, difference cannot be, um, I mean, we have this difference checking, and then if the numbers are matched, and then we add answer. If they don't, we just return and do nothing. Thank you, Carcus. Like, this seems quite legit. And now we're gonna see, I mean, if we combine these two logics, like, does it work or it doesn't? Let's see. Oh my gosh. Thank you, Carcus. Thank you. Yes, let's submit it. Oh my gosh. Let's let's see. Oh my gosh. Yes, as you said, we already have the numbers in our parameters. All right, wonderful. Thank you. Kas, uh, Ka, Kasipita. Thank you. I appreciate it. Wonderful, amazing. So now we've solved another question, which is great. I'm quite happy. I'm quite happy. So now the next, like, I mean, the question before the break is, guys, palindrome partitioning. So we are quite familiar with palindrome questions, but let's see what this little thing is. Um, so, oh, so, mm, all right. It is not about numbers. It is about, that is that is good, guys. That is good. We have like a given a string. Like, we need to, like, basically, if we like, we need to partition, and we need to think like, what are our options. Like, we can, let's say, we can partition by one. I mean, partition, I mean, at each level. Now I'm thinking that what my options are. All right. uh and then, let's say we know our options. All right, we're gonna explore, and then, uh yeah, like, I was gonna say that after finding all, like, at leaf, if leaf, or at the last level, after finding all combinations, we can turn them into a string, and then just we can compare, um, we can compare these strings and see if they match or not. But for that string checking, we shouldn't use, you know equal operator, but instead single value, string value. All right. So let's try drawing the decision tree of this one, guys, and then we can take a break, because uh, I really wonder how we can, like, what our options are. Uh, like like how can we part this apart? I mean, like, A B. So apparently this. So if we have this one, apparently we can select, I mean, we can choose A, and then choose the next, hmm, choose the next A. This is next A, and then, and then, and then B. Let's say this is one way, but at each level we only selected one character. and our options is kind of different. I mean, the number of choices should 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 change, I think. Since the question has an if statement, all right, I don't see my all options. This is what makes this question a little bit harder than others, because in the previous questions I could literally see my options at each level. Actually, in the previous question, yes, in the previous question, the choices, my choices were, clear too, because I had like a opening parenthesis and closing parentheses. But here, like my option, like is my option each characters? I mean, A, B. So do I choose between these options in each level? Let's pick A, and in this level, let's draw it and try understanding it. All right, AAB and AAB. Uh, again AAB. I'm like, let's see, guys. Let's see, because I don't see any other way around. Like these should be our options. I mean, we can shrink it based on some rules, but this is the default options, right? Um, so so apparently we need some sort of integer so that we can decide. We can, but order should be same too. So for example, after selecting A, we have only one option left. We cannot select like a again. So what I mean is that, let's suppose we selected AA, all right, and the remaining part, like if we say in each level the options we have each character AAB, and let's suppose in one node in the tree we have AA as a root, and if we say our options are AAB, then we can select A over here and the string would be wrong. But maybe in each, like in each call we can also like check these comparison, like a string value of, or how do we compare, like this one. I mean, we should compare the strings, their length. No, no, we could literally compare them and check if they are same, and we can have another integer value about the length. All right, we can make these selections, like choices, as long as we are smaller or equal to the length. All right, and in each recursive call, uh, we can check if we find what we are looking for. But guys, the thing is that, how do we actually partition? What I mean is that, like, it says AAB, all right, it says A A, like this question is good, AAB, and also AAB, guys. So how do we do that exactly? Like, this is something this is something crazy. Not crazy, sorry guys, my neck started hurting, so I need to you know put my head like this. So, like, what is the difference? How can we differentiate these two, like a AA or two A's? Oh my gosh. How, guys, this question is crazy. Um, like, oh my gosh. How can we see that? Like, if we pick A, and in this level, and then A in another. Like we need a this is good, guys. This is good. I think there must be a way, obviously, but given a string S partition as such that every substring of the partition is palindrome. We also we also apply the palindrome rule. Um, hmm. What was palindrome again, guys? Let's look at it. Like palindrome should, left side and right, left half and right half should be not same, but is a string that reads same forward and backward. How it is palindrome? AAB, AAB, but this string is not palindrome. Given a string S partition in such way such that every substring of the partition. Oh my gosh. Guys, we can take a break because this question is kinda interesting. Kinda interesting. We can definitely continue with this one. Now, so make it so that AAB becomes anything that are the same backward. What do you mean? I mean, palindrome is a string that reads the same forward and backward, but this doesn't read, same forward and backward. Then why need to be? I don't understand, man. Do we have some hints? No. AA reversed is AA, so it is yes, yes, I know it, but how come this is palindrome? Or this is, or even this? I mean, maybe this doesn't have to be palindrome. Given a string as partition as such that every substring. Oh, now I get it, guys. Every substring. So this is a substring. This is a substring. This is a substring. This is another substring, AA. Alright, now I get it. Now it is kinda easier. Now it is kinda easy. So we need to basically create substrings. Alright, we need to create substrings and return the palindrome ones. Get it? I get it too. I get it too. We basically need to create substring. All so this question is uh, con- continuing continuation of substring problem, and I guess we have solved it, right? I guess we have maximum subarray, jump game, gas station, um, longest, all right, subset, combination sum, subset. What is that? Substring. I guess kind of same. Subsets. Yes, yes, and it is so. It is this question resembles to subset problem. All right, we need to find every that thing. Uh, but how? I guess our options are these characters, but we can use each of them only once. Once, and then when we go one level down, we cannot use the same character. So maybe we can use a start variable and share it with the our children via the argument. Like, it will be great if I see, guys, if I see, like, forget about palindrome, but if I see all the substrings of this S, then I would know how to create my decision tree. But after the break, we're gonna try solving this. Now I kind of understand it. We need to basically create all the substrings and find the palindrome ones. So we need to create a smart way of recognizing the palindrome or not, using a decision tree. And we're gonna do this after the break. Thank you. Um, I think we can take a maybe 30 minutes break. I think 30 minutes will be great. See you after the break. Or 25, I don't know. Make it 25, Ryan. Make it 25. All right. See you. Welcome, welcome, guys. Now we are continuing. We don't need even a break, alright? We don't need that. What we need to do is understanding and solving this question. That's all. See ya. Welcome, Americana. How you doing, man? How you doing? Buongiorno. Por favor. Mexico. Привет. ¿Cómo estás? And je t'aime. And what was like a si, señor. What does I know? Si, yes, si. That was such a combination. Like I love languages, and I hope one day I could speak, let's say, 4 or 5 languages, maybe even more. I like hearing the different sounds. The like, imagine a language comes to your, ear, such different, but that different language is someone's native language, and they try to express themselves, their emotions, anger, and their ideas. But that language is quite, like quite far away from your language. Like that already amazed me. And also it's nice that the phonetics are so interesting. Exactly, exactly. Like I really enjoy. But nowadays I first need to get my life together and learn these things very well, like a Java, Python, and lead code, and then maybe a little bit of JavaScript and C sharp, and maybe a little of Rust. I don't know, but after we got the essential, we should go into programming and also, and reading some papers on AI, or like, yeah. After that, I will start learning some other languages too, because it is quite enjoyable. And I guess you feel the same. You feel the same way, I guess, right? And I wanna learn a new language. No, yeah, yeah. But we, as a engineers, software engineers, we can use both at the same time. Like I wanna learn Spanish, and then German, and then maybe Korean and Chinese and Russian and Arabic, and then what else we have? Like maybe some North Europe language, maybe French. Um, yeah, that's all I think. So now Swedish, yes, is kind that kind of language. Exactly, exactly. Like kind of different, quite different. All right. you know we know the country very much, but we don't anything about the language. So I put that those kind of language in the that box. We kind of know the country, the people, kind of, but we don't hear their language that much. Yes, yes, exactly. You got me 100% Americano. Yeah. So now I guess today I set up the counter like 8 hours, guys. um So let's go fast and try to understand this question. We have palindrome partitioning, and before taking a break, we figured that only thing we need to do, only thing we need to do is um, finding all the substrings, I guess, right? Let's say we have a string A, B. Now we need to like divide and create subsets, but how, man? Like, what what are our options? Like, I don't see it clearly. Obviously, like, if we take the unique numbers, no, like, our I mean, characters are, A and B. And let's say if in our, like, in first, I mean, in each step, if we can use only A and B, but what if we can use B after A? So we don't have this string at all. So that wouldn't work. So we need some other way. What do you suggest, guys? Like, Like if I know what my choices are in each level, then I would try drawing the decision tree. But at the moment, it is hard to see, um obviously we need to create all substrings. So that's the first way. All right. um I suggest where is it? Rosemary oil syrup. Yeah, thank you, man. Thank you, my man. Like this is amazing, man. Like I've been sniffing this for a long time. Let's say, oh, I don't know, maybe over 6 months. And we have. Can you can you see? No, like we have like uh this amount of oil still. But come on, enhance my brain cells, please. Come on. So, like, we need to obviously create the substrings, but how are we supposed to do that? Like we can divide by one, we can divide by two, then three. Let's say, um, or should we do that? Oh my gosh! I guess I have an idea, guys. Is it very expensive? No, no, it is not expensive. Like a coffee amount of coffee, like Americano coffee. Like not that much. Maybe $1, $2, $2, $3, something like that. So I guess, guys, if we have like a string like that, that's cheap. Yeah, cheap. Like not that, I don't know, $2, $3, I guess. So we may divide this by one. I mean, we can take the first character, right? Or maybe first two character, which is two. Or maybe even, oh my gosh, maybe we can even take the whole array. I mean, whole string. I guess, guys, like thanks to Americano and this brilliant stuff. After sniffing this, now I started seeing things differently. All right. So the thing is that, guys, um, instead of thinking from characters perspective, I thought that what would happen if we, you know, uh, like a thing of length, all right? But let's look at the, yes, guys, let's look at this, guys. This means that, like, as soon as you see small amount of number, you should start thinking, yes, that's my time to show off. I mean, show my abilities, all right? What I mean is that this isn't something like a 30, 50, or 100,000, 1 million. It is 16. What it means is that you don't really need to afraid of using recursion and creating decision tree, and subsequently, I mean, using backtracking. All right, this is what it means. That's the clue. So now, let's say we have, let's say, length of 15. What would happen then? We would have, let's say, 15 options, right? We would have 15 options. Like this is not too much, right? We would have, so in each level we would need to make 15 options. But you don't need to afraid, because the important thing is that is not the number of choices at each level, but it is the number of level. Oh, yeah. So in this case, no, guys. In this case, like, what is the how many levels would we have? Since we pick only one character at each level, oh my gosh, like that's 2 to the 16, right? Oh my Wamushinderu, right? um Arigato, guys. um Is it too big, right? Like, is it too big? I mean, like, if we create, oh my gosh, if we create this, like, would my computer would get crash? It is not that big, guys. It is relatively small. Like 6,000, like 65,536 is not a big number, right? Like, it is small. So it is small, right? Anyway, so what I mean is that, guys, imagine we have a string length of 4 a b c d. Forget about palindrome, but we need to, like, we are trying to create substrings. All right, our goal is correct. So what would I do? I mean, what I would do is, I mean, try length 1, try, actually, guys, try length 2, try length 3. So, like, this is basically a b c d, this is a b c, this is a b, this is a. So now what we need to think is, like, after selecting a, our remaining, I mean, here guys, our options are again 1 2 3. All right, but not 4, obviously, because we have, our length is now 3. So again, now we need to make 1 2 3. All right, and when we go one level down, we have 1 2, right? But how about this one? We select a, now we select b c, now we have only one option left. If it is me, I would just split it into one character length, displaying that then moving to length, then again and again until it's complete. It's complete. So second is AAB. So, man, I'm trying to understand this algorithm. Trying, like, you need to draw this, man. That's why, guys. That's why I built this website, so that when you want to try to explain something to me, you can just draw and paste it over here. All right, like this one, for example. Let me take a screenshot of it. Yes, like this one, guys. Because I don't understand from text. I'm a visual learner. I would glad if you do that. I tried, but I really don't understand. That's why I'm drawing this. So, guys, um, as we go one level deeper, guys, all right, our options kinda get smaller or something, right? So, for example, if we make a choice of length 2, our remaining options are selecting one word from the remaining part, obviously. Selecting, I mean, selecting one word, I mean, one character or two characters. After, let's say selecting two characters and then one, and now our only remaining option is, like, selecting one character. And here we don't have anything left. Here we selected ABC and only option is one, and here we don't have any option left. So this seems quite legit to me, guys. What do you say? I mean, this can work, right? Like, this seems legit to me, guys. This seems quite legit to me. All right. What do you think? What do you think? Let's give it a try. And so now we can maybe connect this approach with the palindrome stuff. All right. What was it again, guys? Uh, so among these, I mean, as we reach length 4, guys, we can we can save it. We can save what we have used. For example, we used A, and then B, I mean B, and then C, and we have one more level. And for example, here in this path, we have A, and then BC, yes, and then BC, and then D. So as we reach the length 4, for example, right, we can we can say, like, we can say what we have found. All right, this is one way, but we also now need a like a palindrome uh, recognition system. Palindrome recognition system 3000. All right, we need this machine. Palindrome recognition system 3000. Let's say we picked, like, let's say A B, and then C, and then D. Here A B C D. So which is amazing. But the thing we need to find is that actually, guys, let's say after finding all the temporary arrays, what if we just compare each of them, if it is palindrome or not, and bring. But the idea is that, all right, so sorry, hmm so guys, I thought that what we need to find is like a finding like a AAB, but like a different way. You can create AAB using AAB using like a concatenating A with AB, or AAB. I thought that we need to find different ways of doing that, but it is not about it. It is really about finding subsets. So what we need to do instead is that in each call, guys, in each call, I was gonna say, like a saving this into our temporary or global result, but like A B, A B C, A B C D. Like, should we store pre-orderly and save each of them? Like a, for example, here we have A, here we have B, here we have C. For example, here we have B. I'm trying to find if they reoccur, but I guess not. We have D, we have like A B, I mean A B C D. I guess this would work, right? Like a B C D, like a B C. So this is one. So this is D. Yes, there is the occurrent one. For example, here we have D, and then again D, and then again D. So we shouldn't count it as multiple one. Wait, let me write again since I forgot to save. So, like, you can I mean, you can draw it. You can draw it. Which one was it again? Like this one, yes. Um, all right. Yes. So we need another system for extracting or eliminating the duplicates. But let's forget about it for a second. Let's try to find all subsets, even though we may have like some duplicates or something. Um, so I guess, guys, as we go like pre-orderly, or pre-orderly, um,
upon we call, let's save it. Let's save as an example, all right? Let's save every subset, and then let's have a palindrome recognition system 3000 method, all right? We can call this function, and it can tell us if the subset is palindrome or not, all right? Only thing we need to do is uh, like adding into our temporary array, and maybe even we need to save that temporary array, right? So we have, let's say we have a function, and we have like we are calling this recursively, all right? And we need some sort of for loop, but what sort of for loop? So in each, like that for loop should iterate from 1 to 4, 1 2 3 4, 1 2 3 4. But the thing is, the endpoint should change, because let's say here we pick one character, and then one level below. So as we make a recursive calls for our options, we need to pass the length information. So maybe and -1. So maybe, guys, our function can hold some sort of and argument, and let's say we have a for loop over here, and let's say that this for loop iterates 1 1 2 3 4, all right? But when we are calling, we should call it not and -1, but and -I would be a better option, because based on the length of the current selection, we should shrink our child's for loops iteration number of iterations. So at -I, we should pass this information pre-orderly, all right, pre-orderly. And again, of course, we need some sort of temporary array. And then when exactly should we like save it or something, like a maybe each time, right? So before calling, guys, um let's say so we need some sort of start and end point, and endpoint can be start +1, start +2, start +3, but obviously it cannot start +4. But if start is 0, yes. So what I mean is that we need some sort of substring method, all right? And we can give like a from 0 to end, maybe, I don't know. No, from 0 to I, yes, I suppose. I1, I2, I3, I4. So I mean 0i. I mean 01, 02, 03, 04. So 04 would give us 0, I mean this one, all right, including this one. And let's say we have A, B, C, D, we would get 0, 1, 2, 3. So basically we can get it. So so we need some sort of subsetting method, all right? And also we need to share, like we need to dictate the endpoint shrinking to the next level based on the choice we make. If we make, let's say, 2-character length of 2, we should uh, pass, yes, we should pass and -I, meaning if I is 2, then and should go not to the 4 but 2. So so this is answer, guys. Like this is answer. And also we need a method for like a palindrome recognition system 3000, and we can call this is palindrome method. Or basically we need is palindrome method, all right? And we can put all of our substrings, and it will it can tell us if they are palindrome or not. If they are, we can save it to global answer. So this is answer, guys. We've done it, guys. We've done it. Because at first I thought that, like, what is the decision tree of this one, but and then I figured, like, we figured that like this question is really, resembling to subsets problem, subsets problem. And in subsets problem, all we do, like, a periodically add the what we find on the way down. So the remaining part is only about determining the start and end point of this for loop. All right, we've got it, guys. We've got it. So next question, guys. Actually, I'm still in the process of uploading. I took the picture on mobile and I can send it on stream. So maybe I need to improve it. It should be easy. So all right, in the next stream I will add a feature for mobile so that it is seamless. All right. Actually, you don't seem to be on. Oh, we have Americano Fagoli mobile, but both of them are offline. They seem. That's all right. That's all right. But I will try making this more, VIX, good. So now we see Americano beans. All right. So thank you, guys. Like, our next question is, oh my gosh, I've been looking for this question, but I wanna focus on this in our next stream. Which, guys, I've seen this question in a real interview. All right, it was a big company. I'm not the one who attended, but my friend attended. So I asked him, what did I ask, and he literally explained this question. What does pending host approval mean when oh yeah, we have this. Sorry, let me approve. Sorry, man. I have added a feature so that not everyone can share. Sorry about it. I'm glad you asked it. So now our wonderful, amazing engineer friend Americano, a control feature. Yes, so that not everyone can send messages. So we have AAB, one character, AAB split to one. So split by one, you mean one character. Two character AAB, but the thing is, by two characters you can also divide by A and AB. So you can divide this, split this using like A plus AB. Does your code support this? A plus AB. Like, my idea was just pairing to immediate neighbor, not AB. Just AA, since A's neighbor is A. But in this question, like in this type of questions, we need to discover or explore every possible option. All right. That's why I'm trying to draw the decision tree. Because if you try to make this by iteratively, it is really hard. No, not your bad. I have tried your approach before, and I deeply learned that to be able to solve this kind of exploration problems where you need to find different combinations, permutations, this is area of recursion, basically. All right. So effort well spent on testing the site. Yeah, of course, man. Like, we are live, we don't want to see some bad things happening. So yeah. The next time I can, like, is it comfortable using on phone? If it is not, for mobile, maybe I can create another version so that it is kind of different, but it is easier to use. Yes, yes, of course. So guys, like for word search question is like, I've seen this question in one of the interviews that my one of my friend attended. So this is quite important. All right, we're gonna solve this in our next lead code stream. There is 4 accounts now since every exit. They says, does it now have browser caching? Like, uh, I guess it has one until I shut the session off. Yeah, yeah. So thank you for being here, guys. On Sunday, we're gonna have 17 hours long stream where we're gonna study lead code problems and mostly Python. I will try creating some lists. For example, this is a list for pre-order. I figured that if I internalize this pre-order topic well enough, it will also help me solving some greedy problems, because for this type of question, for example, maximum subarray, jump game 2, like here we have the running state, running some variable where we get history from our past, our ancestors. All right. This is one approach. Like a greedy problem can be divided into, let's say, 7 different types. And once you have, like, once you have solved, let's say, at least 3 questions or 4 questions in each subtopics, then you're gonna be able to, recognize which subtype the problem you have. All right. I really care about it. We can try, solving these, but most probably I will try solving these using AI. All right, because there are some hard, really hard greedy problems. We can continue with, with this pre-order stuff, because I really enjoy solving this type of questions, because it is sibling of post order. And I really enjoy, for example, this question. Oh my gosh. um, these are amazing questions that we gathered using AI. So, um, yeah, we have lots of good questions, guys. Lots of amazing, guys. Using brain is fun. Yes, yes, yes. And also, like, for example, climbing stairs, house rubber 2. Like, these are amazing questions, like amazing DPU questions. I have solved a few of them before, but now I wanna solve them again using, pre-order approach. These are amazing questions. And my goal after, completing this one, and then the greedy, is that I want to focus on, like, a reviewing the reviewing these binary search sliding wheel, the 2 pointers. These are the remaining, relatively easier approaches, but you need to have them in your mind fresh, because easy, you can easily forget them. All right. Also, I have like 7 days plan where I gathered random questions, where I like the questions that I like most. All right. Um, yeah, yeah. So, like, understanding recursion helped me a lot. Understanding almost half of the lit code problem, maybe even more, starting from trees. All right. Um, yeah. So we can also review the sorting algorithms on Sunday. Word break. What was that question again? It word search, right? We have word break and word search. Oh, that's amazing, guys. Let's see how far we can go. This is going to take 6 months. Yeah, actually, yes, yes. Yeah, it takes some good amount of time, actually. Hopefully, before 6 months, we can, solve all of these. Let's see. Let's see. So maybe I can create another, 75 question folder for depth first search. Like this is depth first search with pre-order type, and maybe we can create another list for depth first search. Time well spent though. Yes, yes. Thank you, thank you. Tomorrow, most probably, we are gonna make Python session. All right, and let me look for what can we do. Let's see some lead code. Who is studying lead code right now? Um, let's find someone studying algorithm or building something. Let's see. I can relax on Python session since I will likely just so like I really need to practice Python until Saturday. So tomorrow maybe we can do maybe we can do another stream after the 8 hours. Um, Unreal Engine, Next.js. Let's see. Hold on, guys. I'm trying to find someone. Unity. All right. This seems fine. Copy the name. Python is good for understanding though, since the details are just made. Yeah, yeah. So thank you guys for being here. Let me, see you in our next stream, which is tomorrow. And as I said, on Sunday, we're gonna make great. We're gonna do amazing stream. See us here, Grazia, Perlo streaming. Take care, take care. Um, all right. Do not. Oh, so Rosemary Sniff, before going, you made me so uh, smart today. Thank you for that. Thank you for the Rosemary oil sniff. Um, Roblox studio making. All right, let's pick this one. Rate. Let's see. Oh my gosh, rate settings do not allow you to rate this time. Oh my gosh. Who I can rate, Now my hand smells rosemary. Oil. Um, that is interesting, guys. Why I can't rate anyone? Let's see. Low. You will rate? Yeah, I wanna try doing that because I thought this is the way how we support stream is like I support each other. But I tried two people, but both didn't allow me to even rate. I think they have some setting in our Twitch. Let me try one more person, and then I won't try anymore. Let's see. Oh my gosh, I can do it. So guys, thank you for being here. I see you in next tomorrow's stream. Take care. All right.